Request all of you please take your seat. I request Mr. Janakar to come to the dais and take your seat. I request Mr. Shaiju of MRF to come to the dais and take their seat. Incidentally, MRF is the sponsors of this program. I request Mr. Dr. Srikumar Nair, who is also a GC member from MRF, to take the seat. May I request Mr. Pradeep Kumar, DGM Strategic Sourcing of Ashok Leyland, to come to the dais. I request Dr. Shankar Venugopal of Mahendra and Mahendra to come to the dais and take your seat. I request Mr. Chandar of Royal Enfield, Mr. Ganesh Sundaresan of Yamaha Motors, and Mr. Ghoshal. Mr. Ghoshal. And I request Sudhakar, Vice Chairman, to come to the dais. Now, welcome speech will be given by our Chairman of IRI, Mr. Janakar.
Dear friends, it gives me great pleasure to have all of you for this today's function, being the first meeting of IRI Chennai branch. The topic of today's session, current and future technological development in rubber components, will be of great interest for MSME sector. This topic was selected at the initiative taken by Mr. Cherian, Executive Vice President, Research and Development, MRF Limited. I met him few weeks before, and he was inquiring about the activities of IRI, Indian Rubber Institute. I did mention to him that finance is needed to conduct such meetings. At that point of time, he told me that if IRI can conduct meeting which will benefit the MSME sector, he will make attempts to make MRF to sponsor the seminar. So, with that management, we took steps. I also attended the committee meeting of All India Rubber Industries Association, AIRIA, and members connected with the auto rubber components, particularly Mr. Ankit Jain, Mr. Karthik, Shrikant, Ganesh, Mr. Suresh. They all felt that MSME sector needed technical session. What they should do to produce auto rubber components meeting standards of all generation new vehicles. This I conveyed to Mr. Cherian. He took a lot of efforts on behalf of IRI Chennai branch. for a few minutes for microphone. Hello, hello. Check. Yeah. So, friends, Mr. Cherian took a lot of efforts, and on behalf of IRI Chennai branch, we are grateful to MRF management for sponsoring this event. I must also thank Mr. Shaiju, Deputy General Manager, MRF, for the efforts taken by him. Today, we have with us experts and enlightened speakers from OE manufacturers, and I would like to welcome all of them. In particular, I would like to welcome Mr. Pradeep Kumar, Deputy General Manager, Strategic Sourcing, Dr. Shankar Venugopal, Vice President Innovation, Mahendra and Mahendra, Mr. K. Chandar, Head of Supplier Quality Management, Oil and Feed, Mr. Ganesh Sundaresan, Deputy General Manager, Quality Systems, Global Assurance, Yamaha Motor India. We also have interesting speakers from MSME sector, Mr. P.K. Ghoshal, General Manager, Technical, Industrial Level Products. Of course, Mr. Karthik is supposed to join. He will join later. I would like to say a hearty welcome to all of you gentlemen. I hope that talks followed by interaction between commercial, passenger and two-wheeler vehicle manufacturers will benefit the MSME sector. Technologically, the improvement should be made so that the rubber components made should be exportable and acceptable by vehicle manufacturers, whether they are of European origin or Japanese origin, etc. Like tire companies, if you take, they are technologically in a position to meet the global standard. After all, if MSME manufacturers located in Japan and Europe, if they can make available rubber components for new generation vehicle, in India also we have enough technical expertise to bring forth new technology for the rubber components. Now, Indian Rubber Institute is creating a center of excellence at Mysuru, where there will be research and testing facilities of world-class standard for all kinds of rubber products, and those industries who are wanting to avail the services may contact us. As all of you may be aware, Indian Rubber Institute conducts diploma courses in rubber technology jointly with IIT Kharagpur, and diplomas are awarded based on the question paper set by the IIT faculty and valuation done by them. It will be of the same standard as IIT Kharagpur. For the diploma examination in 2024, IRI is commencing lecture courses in another 2 or 3 weeks, and those of you who are interested may contact us. Just like tire companies, it is my view. The tire companies in India are able to make tires of world-class standard. Similarly, non-tire industries of MSME sector should also be able to produce rubber components. Before the meeting, I was talking to the gentlemen from Ashok Leyland and Mahendra Mahendra. They too are well advanced, but for them to put up factories in overseas countries, even technologically advanced countries, cost is a major factor, quantum of investment and labor factor. So, but even then, they are able to migrate to other countries with CKD condition. That sort of activity they are able to do. If you take tire sector, today technologically, I hope you are aware, we are having the MAG aircraft for defense. The tires were all imported from Russia. MRF made the development, and it was reported the performance of the tires made by MRF was far better than Russian imported tires. You take Apollo tires. They got a factory located at Hungary. They are able to make tires and sell to the European market. You take JT tires. They got a factory at Mexico. They make tires and sell it. Now, talking about MSME sector, you know there are factories from Korea, Japanese. They come and put up rubber component factories. They will be able to do. So, Indian MSME sector also should improve the technology in all aspects, machinery, yield processing, raw materials, etc., so that they are able to raise to the level of global standard. Now, these are the points, and as I mentioned to you in the beginning, MRF has been kind enough to sponsor the event for the benefit of MSME sector. And before we start the technical session, I would like to invite Dr. Kumar Nair, Corporate Manager, Research and Development, to say a few words. Dr. Kumar Nair.
Thank you, Mr. Janagar. Good afternoon, ladies and gentlemen. In fact, it is a pleasure moment to be here today to hear the technological challenges for rubber components from the automotive and the MSME sector experts. In fact, when the proposal came from Mr. Janagar to us to sponsor this event, since it is connected to sustainability as well as to the MSME sector as well as to the automotive sector, our management considered the proposal favorably well and decided to sponsor this event. And thank you, Mr. Janagar, for coming up with such a good topic for today evening. And we have an impressive array of speakers from automotive industry as well as from the MSME sector. I'm sure they will be talking about the technological challenges of rubber and rubber components in relation to the automotive megatrends we call it as CAAC case, which is going to be the next big things in the automotive sector, as well as the sustainability challenges of the rubber components for the MSME sector. I'm sure the tomorrow's products we all like environmentally sustainable products, meaning products with a lower carbon footprint. The materials, the rubber components should be manufactured from sustainable sources as well as circular sources and with a lower carbon footprint for tomorrow's products. And definitely this is coupled with the ethical concerns like human rights issues and so on. So the word sustainability for rubber and rubber related components means has to be derived from sustainable sources coupled with the ethical aspects like human rights issues and so on. And for the small scale industry, these imply big things like huge financial constraints. So eager to hear from the automotive sector as well as the MSME sector on their challenges, with respect to rubber as well as rubber components. And again, thank Mr. Janagar as well as the IRI team in coming up with such a good topic for today evening's discussion. Thank you very much.
Now we will start the technical session. You want to take group photo? Yes. We'll just break for a minute. We'll get down and rearrange for technical talk.
ஒரு சேர்
friends. Hello. So, hello. Yeah. I now request Dr. Mr. Pradeep Kumar of Ashok Leyland to make the presentation. Before that, I request our Vice President Sudhakar to introduce him. You will do? Yeah. Okay.
Wait.
Good job.
Lights on off.
Lights now.
இப்போ என்ன பண்ணுவா அதை காமிக்கலாம்.
Good evening, friends. I have the pleasure of introducing Mr. BP Pradeep Kumar. He is Deputy General Manager, Strategic Sourcing, Ashok Leyland. Mr. Pradeep Kumar has over 27 years of experience in auto OEM and Tier 1 industries. Currently working with Ashok Leyland Corporate Office as DKM Strategic Sourcing. He joined as an engineering trainee with Supreme Industries Mumbai and worked in their plant at Pune and Mumbai for 4 years. And from 2001 onwards, he is with Ashok Leyland for last 22 years. He holds a master degree in polymer technology and master degree in engineering management from BITS Pilani and a certification course in management from IIM Bangalore. Over to Mr. Pradeep Kumar.
Good evening, friends, and thank you very much for giving this opportunity for auto OEM that to Ashok Leyland as a commercial vehicle industry person. It gives a lot of pleasure to be a part of the MSME sector. Can network with many of our known persons over here. Mr. Ghoshal, many of our known persons are here. And many new faces, and there's also an opportunity to network with people of Yamaha, then Mahindra, etc., and MRF and all those. Idea is that these days is expanding in terms of technology, in terms of the sustainability, as Dr. Nair rightly said. A lot of things are happening. So networking of this kind will always help each other, an OE or MSME or a Tier 1, Tier 2, etc. So thanks a lot to Mr. Janagar calling me for this presentation, and Mr. Ganesh, thanks a lot. So I will try and explain the content slide. I will try and explain what exactly is the technical challenges are there, plus what all the managerial changes are there going forward. Next, let's say next 5 to 10 years. This is what my content will be, right? Thanks a lot. So, as I told you, current and future developments in rubber and plastic industry. I'll also touch upon plastics for and expectation and opportunity to work together, and especially commercial vehicle industry. So before starting, I would like to give a small introduction of my team also. Mr. Manoj is working with me. You can. They have only put this presentation forward. So Mr. Akash Arnav, Mr. Bharani is a IRI member also. Thanks a lot. So we are all working out of corporate office from Gindi. Yeah. Next slide. So this will be my content shortly. As I told you, I cannot leave Ashok Leyland, that being my parent company. Then a glimpse of what is commercial vehicle industry altogether. Application of polymers in commercial vehicle industry. Now we will find also the technology movement to meet the industry requirement. This is some sort of technical glimpses that our team is trying and giving you, which is in rubber and plastics part. Then the buzzword, explanation of the buzzword, what is alternate fuel and how it is affecting the commercial vehicle industry and the roadmap of it. Then the next point is on the environmental social governance, which Dr. Nayak also said, and the circular economy, and what is the readiness and expectation out of the MSME and wages. Then a slight part of it will go to opportunity to work together for both of us. That is how the presentation is clubbed. Thank you. I will take the next slide, please. I will take these slides a little faster. Next slide. Yeah, so Ashok Leyland, I'll take these slides, 2-3 slides I have made on my company. It's a multinational company founded by SP Hinduja and 37 countries, more than 70,000 employees, turnover $50 billion, etc. What is important is 75-year-old company having guiding principle. Mr. SPD Hinduja made this all the guiding principle. What to give, what is the bond, and local think global, partnership for growth. This is what we always believe, partnership for growth with the tier 1, tier 2, etc. Advance fearlessly. These are all things which he postulated 75 years ago. This is what I want to say in this slide. Next. Yeah, so we'll talk more on automotive only, whereas the interest of Hinduja Group is in chemical use, banking, etc., etc., etc. I am not going into that. Automobile will only concentrate. Next slide, please. Here is what, around 40 kilometers away from this place, it is Ennore. So there Ashok Motor founded by Sri Raghunandan Saran, I think 5 kilometers away from the MRF factory, and incorporated in 1948. It was assembled Austin car. Somebody will say Ashok Leyland is a truck maker. No, Ashok Leyland is a car manufacturer in 1948, which became truck manufacturer later on. Then collaborated with British Leyland Motors in 1954 and changed Ashok Leyland on the son of Raghunandan Saran. It's Ashok, therefore the Ashok came and Leyland came. Company started manufacturing MNC on government license, jointly acquired by Hinduja Group. From 1987 onward, it is Hinduja Group. Then it went on Hosur, Alvar, Bandara, Pantanagar, etc. with the capped capacity of around 2 lakhs vehicles per annum. Next, please. So this is our vision to be top 10 global CV player, creating reliable and differentiated products and solutions while delivering outstanding stakeholder value. Top 10 global CV player is what is our ambition. Yeah, next. So as I said earlier, we will just discuss what is commercial vehicle and industry in India specific. What we are talking is Indian automotive industry is having a total vehicle of $120 billion and 45% of the entire thing is coming from commercial vehicles. The pie chart shows that. And what is important is India is the 4th largest CV manufacturer by volume in the world. You can guess number 1, number 2, and number 3 also probably. Number 1 is definitely, you will say it is USA. Number 2 is, you will say it is, somebody can guess it. Number 2, commercial vehicle, it is China. Number 3, people will not even think about. Number 4 is definitely, India. So number 3, when we made the presentation, even I was also, kind of. So number 3 is Canada. It is really a surprising element. So that is how it is. Ashok Leyland is second largest CV manufacturer in India. market leader in bus, 18th largest truck manufacturer in the world. And we are saying the Indian commercial vehicle industry is growing at the pace of 5.2% with the compound growth rate is what we are trying to say. Next slide, please, sir. So, just an explanation of what is commercial vehicle. We talk about the LCV, which is lesser than 7.5 ton gross vehicle weight of the vehicle. Then we talk about intermediate commercial vehicle between 7.5 ton to 16 ton. We call it ICV, that is intermediate commercial vehicle, finding application inside the city, etc. Then we talk about the MNHCV, medium and heavy commercial vehicle, more than 16 ton. And there are buses also of 16 ton up to 80, 16 seater and 80 seater respectively. Yeah, next slide. So now I think having given a understanding about what is commercial vehicle and what is Ashok Leyland's part in that, feels like to go to into the application of polymers in commercial vehicle industry. What is what? So what is really happening in the commercial vehicle industry? Not into cars, etc. Two-wheeler. It is purely commercial vehicle. So we talk polymer based part into two different verticals. One is non-metal, we call it as. I head the entire group called as non-metal domain. So this is non-metal chassis parts, majorly of tires and non-tires we talk about. Non-tires we talk about, and cabin parts. We talk about cabin interiors, which is basically of windshield, front grille, roof liners, etc. Carpet, steering wheel, and all the interior. Exteriors, we talk more on front grille, flaps, fenders, mirror, logo, etc. These are all the cabin parts which are coming. And the main rubber components where it is getting used in the commercial vehicle area is definitely tires. Auto majors there, MRF, Apollo, etc. Then something on the gasket. Here is where the majority of the rubber components are getting. Engine hoses, mounts, etc. are coming. Modular hoses, fuel hoses, these fuel tanks, etc. are plastic in nature. Next slide, please. So here is where the schematic diagram on this, where is what, etc. Windshield, seat, and roof liners, ORVM, air piping kit, and all those. Proud to say, Ashok Leyland is doing a lot of innovations in many of the polymer related area. Our suppliers knows about it. Now, one point I would like to say, the plastic fuel tank which you are seeing over here is the first of its kind in India who introduced a polymer tank which is of XLPE, I think 15 years ago. We are the patent holders of this list. Thank you. Next. So, in summary, around 25 to 30 different part families, we call it the CAC hose, cab mounts, then oil seals, etc. and rubber. What are all the raw materials? What are all the different processes we are handling? And the application is what my team has made for me. Next, please. So, this is an atlas of the complex raw material that we handle. We will be more interested in the coming slides. We'll be talking more on the this particular center area. But otherwise, the material that we are handling is of plastic in nature, which is ABS, PP, XLP, MDP, PA6, PA66, PA12. All this PA is nothing but polyamide, which is nylon. This is Hytril of DuPont. Then something called as FRPP, sheet molding composite, SMC, polyethylene, thermoplastic olefins and thermoplastic elastomers. Then the rubber area, we talk about natural rubber, EPDM, neoprene silicone, etc. VAMAC and advanced chemicals you will find on the bottom, which are VAMAC, etc. And we consider the others polymer also, which is inorganic polymers. We call it as polyvinyl butyryl, we call it as glass, ceramics. All these are finding application in a typical vehicle in Ashok Leyland. Therefore, more than 30 different polymer material and its components have been used. So, what is the area diagram? How it is looking like? The area diagram is looking something like natural rubber is constituting more than 30%, which is in tires and dampers, and XLP, as I told you, fuel tank, cross-linked polyethylene we call it as. So that is also covering 10%. Polypropylene dashboard components, etc. Cabin interiors and exterior, this cover another 10. Carbon black is another part of it. in the rubber part, this is also major pie in natural rubber. ABS, acrylonitrile butadiene styrene, then PA12, EPDM, synthetic rubber and all those, and a very high technology related, application related parts, these are all going. Therefore, if you really look at where all this commodity coming from, only this polypropylene is getting manufactured in India, otherwise all are coming from either Poland, USA, China, those countries. So I am trying to say all the 70% of all this are imported. Therefore, again, a question comes to MSME and the rubber fraternity is that how long we are going to import, which is not cost sustainable and availability sustainable. Previous slide. Next slide, sir. Next slide. Yeah. So this is what the area chart of what is really happening on the buying percentage. China still we are dependent a lot. Korea we are dependent. Singapore, USA, Thailand. These are all the countries that we have made in the area chart. Next slide. So having said that, when Janardhan sir asked me one question that why you guys are not putting your plant in abroad countries, so I had to answer saying 30 or 40,000 components, indigenousing will be a problem. So therefore, a question over here is why can't we make this raw material in India? Maybe this is one of the points that we can take up as MSME. So next point what we are talking is technology movement to meet the rubber industry. We'll talk something on the technical of rubber and plastic part. What has really happened is this will talk about the emission norms. Majorly vehicles are getting graduated on the emission norms. Therefore, from 2000, 2005, 10, etc. European Union has migrated to Euro 6 norms somewhere in the year of 2017, and India has moved to Euro 6 norms, BS 6 we call it as, in somewhere in the 2020, and we have skipped the BS 5 and then we have moved to BS 6. In other countries you will see still the BS 5 or Euro 5. So what does it mean to a vehicle? Is the complex exhaust system, after treatment system, higher operating temperature, plus 300, etc., higher operating pressure. So these three are culminating to these many things: need of a high performance polymer, more import content than local, more and more we win the import than local, costly raw material, lack of alternate source, monopoly to few raw material manufacturers like DuPont, etc. earlier. Adaptation of new technology is not very fluent. So some design related, material related, process related points we have tried to bucket over here on the BS6 onwards. One is definitely higher compound formulation to meet the noise, vibration and harshness requirement of the vehicle. People have to go for a higher design. Global formulation to meet global standards, because many of the parts in the last 4 to 5 years we had to indigenize, which we are importing. So meeting that compound formulation were a little difficult, and oil seals etc. have gone to one origin to another type, and some design to suit EV, LNG etc. And what has happened in the material side, from EPDM to EPDM ECD type, that is peroxide type EPDM. Then from NBR to silicon white-on combination, silicon to silicon white-on combination, especially in CAC area, etc., ACM to AEM. And in the process, what we are really saying is that gone are those days when we did the compression molding, etc. We talk more on injection molding, or 100% on injection molding these days. Molding to extrusion, cryogenic deflashing, these are all the continuous process lines, etc. So one typical example, or two, we'll try and give it over here. Earlier we had this CAC hose in terms of silicon. Now to meet the temperature and pressure, the inner had to be in a white-on material and outer had to be the silicon material, is what we are doing. Earlier we used to give the print of this to the suppliers. Now it has become a proprietary part from the supplier, meaning supplier has to do the validation verification of all this and submit this as a component with their DVVP. That is the point. So the supplier has to set up all this axial stiffness machine, PVT, test setup, and all this has to be met by the supplier. Next slide. Another area wherein a lot of changes have taken place is on the EPDM hose, wherein sulfur cure to peroxide cure. Although the cost and the productivity has not met our expectation, but we had to go because of the newer the cooling material and all those. So this is what from normal EPDM we have to go to the ECD type. Next. Here, what we are talking is we had a lip type configuration on the oil seal. People from Fenner will be definitely able to appreciate this. Then we have to completely change over to a surface type PTFE kind of a seal. So if you see the graduation or its movement from leather to nitrile to polyacrylic to silicon to fluoro and then to PTFE. These all have increased the cost of the component and definitely performance has increased. I'm talking on the BS6 perspective. Yeah, next. So this is on the how PTFE seal has affected the performance, etc. We are trying to say on the temperature and other area. Definitely, it has also had an impact on the assembly inside the factory. We had to change certain assembly procedures also inside the factory. Some area on the rubber hose wherein we had a braiding kind of a technology earlier, and it has moved to knitting, etc. So these are all the technological advancements which has taken place in terms of BS4 to BS6, and when BS7 comes, there are a lot of other technology things are also. I think you guys will be also working on that. So we would request you to come and discuss with us. Therefore, we will also be taking it forward. Now, what is the next generation? How it is looking like in a commercial vehicle? One, definitely people are working on the alternate fuels for zero emission, and second, of course, lightweighting is the area where all OEMs are working to make the vehicle very efficient, fuel efficient, and especially on the EV space. And this one, more and more you are finding a driver as a owner, or owner as a driver. Therefore, he wants the comfort of the vehicle to be like car-like. So he wants a world-class cab interior with all plastic parts. This is how the Indian industry is moving. So here, if you look at EV is coming, CNG is coming, LNG is coming, hydrogen is coming, LPG. Earlier, this was only diesel in commercial vehicle. This is the point here. Therefore, polymers play a vital role taking ahead technology for cleaner fuel and providing more cabin comfort also. So this slide is giving a glimpse on what is happening. You can read this area and come to this place. What is really happening is that during 2020 we had three different area. One is on the gasoline engine, second is on CNG. Electrification was a smaller pie of it. If you come to 2030, these are all the things which are going to get migrated. Therefore, instead of three, you will find gasoline is there but diminished in size, and electric is there but has increased in size. This was not there. This has come over here. CNG has come over here. What is important is hydrogen as a fuel has come over here. LNG also has come over here. So all these have come in the year 2030. So all this migration will take place. Some disruptive change also will take place in the gasoline to LNG and electrification also. Yeah, next slide, please. So here, this slide is a very interesting slide. Like I said earlier, the three different classification of commercial vehicle industry, how it is going to move. We said LCV, light commercial vehicle. You have to see over here what is high and low. What will happen in LCV vehicle, smaller tonnage vehicle, after 10 years will be more towards electric and CNG. It will not move to LNG or hydrogen. It will be staying within the two. And ICV, it will move to probably to CNG and a little bit in electrification, but it will slightly move in this hydrogen area also. But if you look at medium and heavy commercial vehicle,
it will not be electrified. The vehicles will not move to electrification area or CNG, but it will more of LNG and hydrogen. So the hydrogen as a fuel is going to evolve, and in our technical center, we call it as value oil choice. A lot of work is happening, and we have also in the last Auto Expo, we have showcased a few vehicles also in these two spaces. Next slide, please. So similarly, the buses. Buses, what will happen is definitely it will not migrate to a hydrogen perspective. It will stand with the electrification and CNG. Electric vehicles and CNG is what is the future in the next 10 years. So this will give a glimpse on what we have to work on as a supplier fraternity. What we have to understand is how the fuel is going to get converted in the country, and how we have to place ourselves in terms of the research for a polymer part or any other vehicle part. That is the underlying question. So that is the point. Next slide, please. Yeah. So the another very important point, very challenging point is how are we going to be a net zero? Now we talk more on what we call it as technology changes. What we call is it really challenging? I would say technology is available elsewhere. It can be we can research it and we can make it possible. But what is really challenging is how are we going to make our company as a net zero company, which is carbon zero company. So Ashok Leyland has got this is the roadmap for Ashok Leyland. By 2035, Ashok Leyland should be net zero on carbon emission, carbon supply thing. So what is how the roadmap is? Therefore, there is 2014. We have already started. Supplier code of conduct finalization, digital ESG platform, and 100 supplier has been inducted, baseline, etc. we already done. This is an interesting area. In the year 2025, we are going to handhold more suppliers, and we are going to engage further 200 suppliers, which is 90% by value. We are going to do, and 10 to 20 MSMEs will be engaged on ESG tool in the year 2025. While we are touching more of the proprietary companies like Bosch, or for example Saint-Gobain, Asahi, etc. Here we will be concentrating more on the MSME, and by 2028 all MSME has to be engaged. This is our mission, and 2030 will be a year where we will declare around 50% is completed, and 2035 we are saying we are net zero. So that is a message that I would like to give, is that we would like to have support of all the MSMEs towards this thing. Then a few of the examples which suppliers have already done. One is having a solar panels is done by one supplier in Hosu, completely solar panel. Therefore, inside his factory, you find everything is working on a solar kind of a setup, and completely DG etc. not there, and this is what we mean. So these are all few points wherein the MSME can work. Diesel to LPG, solar cell, some blended fuel, ethanol blended fuel, variable frequency drive in their the equipments etc. they can go for. Next slide, please. So here is where another great challenge which is coming is on the circular economy. What is really circular economy? How much of the scrap that you are going to use in your vehicle, that is called a circular economy, right? So if you are generating, let's say, 10 kg of scrap in the vehicle, in plastics or rubber or steel or casting forging, how are you going to use? So in our company, BS6 and alternate fuel norms, technology upgradation and availability of high performance polymers. Third is on the indigenization, thrust on indigenization and reverse engineering capabilities. I would say that we had taken more than 2-3 years to indigenize some of the components because the specifications were not available. So here, a capability enrichment or enhancement is definitely required. If somebody is coming to us, we can definitely discuss on that. And I spoke on the ESG, which is on the environmental social governance and the carbon neutrality. We need your support on this. Circular economy, like I said, the support for scrap-based policy, recycle and reuse, especially on tires and other thermoset polymers is what we want. With this, I would like to end the presentation. Hope it was interesting to you. And if any points are there, you can ask questions now, or else we can take it later. Thank you very much. Thank you.
We will go ahead now. We have a question and session a little later, but I will now request Dr. Shankar Venugopal to make a presentation. And
Thank you.
Will you introduce him?
Back up like that. Back side or front side? Back. Check. Okay.
I have the pleasure of introducing Dr. Shankar Venugopal, who is working as a Vice President in Mahindra and Mahindra. He leads the technology innovation and intellectual property portfolio for Mahindra Automotive and Farm Business. He is the Dean of Mahindra Technology Academy. Dr. Shankar has lead technology innovation at GE, Dow, Honeywell and Cummins prior to joining Mahindra. He holds a PhD in material science from IISc and a management degree from IIM Bangalore. He is the prolific inventor with 20 international and 8 Indian granted patents. He has won IISc Best Thesis Award, GE Edison Inventor Medal, recognized one of the top 50 EGMP graduates from IIM Bangalore, and with Prolific Inventor Award from the World Intellectual Property Forum. He was a member of B20 Task Force for Driving Technology, Innovation and Research. He is the author of the book Mobility Engineer 2030 in Tamil, that describes the future skills required for the automotive industry. I think that book will be of great help to our MSME sector, so it can be distributed. Thank you, Doctor. Over to you.
friends, happy to be here. I'm Shankar. Till my slides get up and till this starts working, have an informal introduction to the topic. So, our friend Pradeep Kumar spoke about commercial vehicles, and I'm going to focus more on the personal vehicles, and that's what you and I drive, so we can relate a lot more to what's happening in that space. And within that, specifically, I want to focus on one very specific topic that's totally disrupting the personal vehicle space. And a lot of what I want to discuss with you today will be very limited to that particular aspect. So you have been seeing all the new vehicles coming to the market from Mahindra and many other automotive players. What do you see as a key trend? What do you expect to happen as something totally new and disruptive in the next couple of years? What do you see as a big change?
Driverless cars.
Driverless cars? You see driverless cars on Indian roads? Or do you think it will take time? What is your thought? It will take time. It will take time. But also I'll tell you what is already happening versus what will take time. Definitely talk about it. What else? What is here and now? Just round the corner. Electric. Sure. So I will focus primarily on the electric part. And the requirements for electric car are very different from the requirements for the IC. So there's the opportunity for us to innovate and build new businesses around there. So I will definitely spend some time talking about it. And then you can further think about whether you want to play in that space and do something for the space of what is. So my background, I studied physics and I did a PhD in materials and I got into the industry. Currently with Mahindra doing technology innovation for new products. But I never thought I'd be speaking to an association of rubber technologies. This is something very unique, something special to me because of something very funny. My own experiments, the very first experiment that I did in my life was at the age of 7 or 8. Somebody told me that you can make rubber, and I was excited about it. And you know, a 7 to 8-year-old kid at home doesn't have access to resources, doesn't have much. But the process they said to make rubber was fairly simple. Yeah. It was very tempting. The way it was described to me by some another 7 or 8-year-old kid was so tempting that anybody can feel like, why not we go ahead and make rubber? Process is very simple. I tried for almost 2 months, initially without the knowledge of my parents, later with the knowledge of my parents. But somehow, I could not make rubber at all, in spite of varying different process parameters. I could not make. Can you guess what my raw materials were? Because the person who told me was 100% confident that you start with this, you will end with rubber. And the raw materials were something very interesting. Pencil sharpenings. Okay? Have anybody tried making rubber that way here? So you can. So you know that. So the first material is pencil sharpening. Second is very commonly available milk. Milk with cream if you have access to it. Okay? They said all you have to do is heat this, you'll get rubber. I tried quite a few times. I never thought that with this series of failed experiments, I will never ever do a PhD in materials. But somehow I ended up doing it. And today I'm here talking to a bunch of rubber technologists with such a poor experience in rubber. Sure. So, I focus a lot on making mobility sustainable. That's my interest in electric vehicles. I have a few patents, and before I landed in Mahindra, I worked for GE, Honeywell, Dow Chemicals, and Cummins. Okay, so you can move to the next slide. Yeah. So this is something I'm sure all of us can relate to in terms of what are the problems when you're looking at mobility. One is definitely the tailpipe emission. Pradeep talked about BS4, BS6, and how the emissions is steadily coming down. Suddenly with the electric, it will be zero emissions. There is nothing to emit at all. So that's the biggest attraction for all of us to move towards electric. Second is, we do still see accidents happen. And if there is a way to prevent accidents from happening, then that will be the next big thing to make mobility very sustainable. Last but not the least, I spent a good part of my time in Bangalore. So how many of you have driven in Bangalore? Okay, so you know how the situation is. That's the last picture there. Any time of the day, wherever you are driving, it's going to take you ages to reach your destination. So if you are in an electric car and if you are in a traffic jam, do you think it will help you in any way? Not really, isn't it? Just making it electric and emission free alone cannot solve a traffic congestion problem, which we expect to see in almost every city in India. So we need to think little beyond and see what other technologies will make it meaningful.
The other way,
Yes.
if you are in a traffic in an EV vehicle, the battery will get drained out.
True, very true. That's even more a concern. Yes. So, a lot of what we are pursuing today is an electric vehicle along with connected, semi-autonomous. Semi-autonomous means today a Mahindra vehicles like a XUV 700 or a Scorpio N will have self-drive assist features like parking assist, lane deviation. All these are available today. You can buy a car with all these features. That is what we call as level 2 autonomy. We have level 0 to level 5. Level 5 is totally hands-free, but today we are at level 2. And then it could be a shared vehicle, because the earliest adopters of electric are the Olas and the Ubers. So it could, in all probability, be a shared vehicle instead of an individually owned vehicle. It's a combination of all these four that has the potential to address all the three challenges that we talked about earlier in terms of reducing the emissions, making it safe, and also managing through all those traffic jams and congestions. So electric alone cannot solve, but electric along with all this has the potential to do this. That's why we are putting a lot of our bets on electric as a future mobility option. Can you move next? When you look at electric, there are at least three things which make it very, very attractive. Fuel economy. Typically, if you are running an engine with a fossil fuel, you're talking about 20 to 25% kind of energy efficiency, because you are converting a chemical energy into a mechanical energy. But if you are using electric vehicle with a motor, an electric motor, where you are looking at electrical energy to mechanical energy conversion, efficiencies are 80 to 90%. So that's one big attraction. Suddenly it's a threefold jump in the energy efficiency if you are switching to electric. Second is, there is absolutely no tailpipe emission. There's one catch here. Every day you are going to charge your electric vehicle. And if the electricity comes from burning fossil fuel somewhere, then I cannot say no tailpipe emission, because I'm just shifting the emission. So it means I should also generate electricity from renewable sources like solar, wind. If I can ensure that, then I can boldly say that zero tailpipe emission. And the total cost of operation is significantly lower, because not only the fuel cost, even the maintenance and repair cost is very minimal as compared to today's IC engine based vehicles. So all this make it very attractive to look at electric. But those of you who have seen an electric vehicle know that it's a real paradigm shift, because if you open the front bonnet of the car, you're so used to seeing so many things out there, and suddenly you'll see none of that will be there in electric car. This is a Tesla Model S, where the battery pack is on the floor of the car, and the motors can even be hub motors right on the wheels, So you don't have anything in the front boot. So this is a paradigm shift, not just because you don't have all those components, but for something else, which is even stronger than that, which you will see. These are all the components that were under the front bonnet. So all these components you can recognize, they are no longer there in the electric car. So as an automotive OEM, we have to take our entire supplier ecosystem along with us. We have to help each one of them to find and repurpose themselves so that we'll be able to build a whole new ecosystem around the electric vehicle. We can't do it alone. We need the support of all MSMEs and build a very strong ecosystem of suppliers for electric cars. That's when we will be successful. But the good part is, today, if I ask you, if I give you an electric car at the right price point, are you ready to switch over to electric? There could be a few concerns that you may have. One is the range anxiety. We are so used to filling with petrol or diesel and just driving without worrying about it will ever stop somewhere halfway through. But that is going to change with electric. And also today the battery is expensive, so the initial cost is little high. And it takes time to charge. Okay, if you are driving somewhere and suddenly you run out of it, you just cannot quickly charge and move on. You have to spend finite time to charge it. So that you may not like. Today you are just driving in and driving out of a petrol bunk in 5 minutes. If I say that you have to wait at least for 1 hour, even if it's a fast charging station, you may not like that idea of waiting 1 hour in the middle of your trip. But interestingly, if you can just move back for a second, all of them can be tied to one key component in this vehicle, which is the battery. You can innovate and improve the battery, then you can address all the three concerns. Because if the battery stores more energy, I can drive longer distance, so the range anxiety goes away. If I can do something on the battery and innovative to bring down the cost, the initial cost also will come down. Same way, if I can charge the battery faster by going for a new chemistry, then I need not wait for that longer time to charge. So all this makes it very, very interesting. But before I get into details, if you want to play in the EV space, I told you so many components are going away, they are no longer there, a whole new ecosystem is coming up. But one thing that doesn't go away, still remains same, from IC vehicle to an electric vehicle, you know what is that? Tires. Luckily, the tires will still be there. Electric vehicle will still need 4 tires for it to move, which is good news for many of us here, correct? But do you think the tires that you supply for an IC engine vehicle, do you think will it work for electric vehicle also? Yeah, feel free, So, do you think the electric vehicle will need certain special requirements, some special properties from these tires for optimal performance? What do you think? Because if you discuss about this, then you will be able to go back and come up with the right technologies that will help us to optimize the performance of the EV by putting the right tire there. And that is not just Indian market space, that's a global market space for each one of you here. So let's talk about it for a couple of minutes. So what do you think will be different? Why should the tire of an EV be different from the tire of an IC vehicle? What is different? Weight. Sure? Load distribution. Okay? Weight is more, absolutely. So all of us are on the same page that the weight of an electric vehicle will be a lot more than IC vehicle. Roughly 40 to 50% higher weight. So the tires have to take the additional weight. Load distribution. Engine was in the front. Now the battery is across the entire length of the vehicle. We call it a skateboard architecture. It's across the entire floor. So the weight distribution is going to be different. Fine. What else? What else will be different for electric car? Huh? High abrasion resistance because of the higher torque. Absolutely. Perfect. Speed, higher speeds. Sure. What else? Noise. Who said noise? Can you elaborate on that? Yeah, just a little bit more.
Plan for small mileage,
Yeah,
get not noise automatic.
correct.
Lesser mileage, more braking efficiency.
Yeah.
Smooth tires,
Yeah,
noiseless.
noiseless.
There has to be a compromise between this and
Sure, sure. You want to add something to what you said?
When a survey of a Tesla car was going on, so they understood the main problem what the drivers are feeling, that the noise inside the cabin is more. So they wanted that some compounds to be added on tire which will make it quieter.
You know what? See, today we can live with many noise in the car or any other vehicle for the matter, because the engine makes so much noise that every other noise is submerged. But the electric car is a very, very quiet place. There is no engine, there is absolutely no noise. It's so quiet that any other noise really becomes an irritant, one of which is the tire noise. More importantly, we talked about, yeah, please.
are they really pollution free? Is it environmentally friendly?
For the electric car? Yeah, we'll come back. That's a much longer discussion. We'll come back, definitely. Sure. The battery has limited energy and you want to drive as much distance with that energy as possible. So you want to minimize all other energy losses, one of which is the rolling resistance losses. So you want to optimize the tires so that it has a very minimal rolling resistance. You also want to make sure that it can handle more weight, but at the same time, it should not be heavy. It should be light, because I want to make the vehicle as light as possible so that I get the best possible range. So I want it to be light. So it should not be heavy. Pardon? Correct. True. True. We have to modify a lot of things and optimize from that perspective in terms of its weight bearing capacity, the traction forces because of the higher torque and higher speeds, and also the amount of heat that gets generated. We are also talking about regenerative braking, where when the vehicle brakes, we want to recover that energy and store it in a supercapacitor and use that energy, because every little energy matters a lot there. So it's going to see more heat and we should be able to come up with materials which can handle that. Okay. So there are a lot of things that one can do around the material, the way it is being processed, and the way it is being shaped to form a tire that delivers optimal performance for the electric car. Also, the electric car, the tire is the one which is in contact with the road. Okay. So the tire can do a lot of very useful work for the car. For example, the unevenness of the road, based on which if the car's speed and suspension, everything has to be optimized, that intelligence will come through the tire, because that's the one which is in contact with the road. So we look at embedding sensors there so that it can map the road. As you drive through one road, it would map exactly where there is a hole, what is to be done. So the next time when you do, the car will already know and it will. Today, these technologies are very accessible. It's not at all difficult. It's not at all expensive to implement these technologies. A more important thing is, we always talked about range anxiety. You said if you're stuck in a traffic, you lose all the battery's charge doing that. Is there a way that as I drive more distance, I accumulate more charge? Is it possible? So that as I keep on driving, I keep on accumulating more and more charge in the battery. So there are people who are working on this idea of wireless charging, that to dynamic charging on the go. So typically what happens is there will be on the road a metal strip through which inductively the electrical energy is transferred. And how it will be transferred? There should be something on the tire to receive that and pass it on to the battery. Okay. So the tire, apart from just having a tire pressure sensor and basic sensors, now it is going to have many more sensors which will actually make the vehicle very intelligent going forward. So there are some fundamental changes to the properties of the material, the way it is being processed and shaped, but also all these embedding sensors and controls, the hub motors will be right on the wheels. So all this is going to happen, and that's why the wheels, the tires for electric cars is going to be quite different from what we are all using today for the IC vehicles. But the battery is going to be the new hero for all this movie that we are talking about. The battery is right at the heart of it. And whatever we do, the battery is going to control the cost, it's going to control the performance. So we need to have a reasonable play in the battery space if we want to really go global with electric. You can change the next one. You can move to the next one. The materials that go into the battery, the lithium and cobalt, they are scarce materials. So the price of this material is going up steadily because of the demand. As we make more electric cars, the price of this is expected to further go up. And that's not a good position to be in if you want to make affordable electric cars. Primarily because the lithium for the battery comes from only 3 places in the world, primarily. Can you guess what those 3 countries could be? China, I'll tell you, I'll come to that. The raw material comes from Argentina, Bolivia, Chile, and Australia. 4 places. China just has long-term trade agreements to get it and process it. But otherwise, China also doesn't have lithium. It's only these South American countries and Australia that have lithium. Along with the lithium, I'll come to that. I have a slide on that. Just 2 minutes. I'll be there. There is one more element that goes into the battery, that is cobalt. Can you guess where cobalt comes from? There is only one country which supplies cobalt. Congo. Okay? So this is the situation. Imagine the technology is very promising. The vehicle that you build out of it is really good for the environment. But when you look at what goes into it, it makes you really worry. I cannot sleep if I say that the material which goes into the heart of my vehicle comes from only 3 countries, and another material comes from only 1 country. Somebody like Pradeep who has to manage the entire supply chain for it, he'll say, he'll go crazy. He cannot go home, he cannot eat, he cannot sleep, he cannot do anything. That is the situation. So, that's a story. Those colored regions are the only places. So, there China is also included because it's processing all of that. And if you can go further up, this is where the movie changes. Many of the movies now, after interval it will change. Have you seen it? Till interval it will be one way, and after interval suddenly it will change. So now, since my time is also limited, I'm going to quickly move to the second part. First part was all constraints, isn't it? Looks like it's just not possible. It's all very negative. How is it? It's possible. Now I'm going to change the story and say how it is possible, for which I'm going to tell you a story which all of you know. But I want to remind you of that story. So there was this Rakshasa who prayed to God and said, I want to be invincible. God said, come on, everybody who is born has to die. I cannot make you invincible, ask for something else. So this guy asked for 4 or 5 things. He said, no human should be able to kill me. And I should not be killed either in the daytime or night time. I should not be killed either inside my house or outside my house. I should not be killed either on the ground or in midair. And no weapon should be able to kill me. Kind of exhaustive, isn't it? He has kind of explored all possible things and almost made sure that he is invincible. So he becomes very arrogant, goes around and troubles people. Then people go back to God and say, what is it you have done? This guy is already bad and you have given him superpowers. You do something about it. So that's when God comes. And then he comes as a lion man. So he is not human, he is not animal. This is a Narasimha avatar. So he is a hybrid. And what time he comes? When does he come? Twilight. Those 2-3 minutes when it is neither day nor night technically. And then he can't kill him inside the house. He can't kill him outside the house. So he brings him to the doorstep. Okay? He can't kill him on the ground, neither in the air. So he puts him on his lap affectionately. And then he can't use any weapon. So what does he do? Claws. Okay? So that's a happy ending to the story. But the thing is, any complex problem, if you look at it together, it looks like you just cannot solve. We don't have lithium, we don't have cobalt, we can't do this, how else to do? But if you take one at a time and look at it, it's very obvious. Because when I said you can't come in the daytime or night time, somebody immediately said twilight. Simple. It doesn't need a Nobel Prize brain to really crack a problem of that kind. So the idea is, don't look at it as a complex big problem. Try to split it as individual problems. Then you will be able to very quickly come up with very practically implementable solutions. If you just go, here's where I want to share the second story. How many people from Kerala here? Can you just put up your hand? This story is from Kerala. So thanks. So there is this king in Kerala who was very fond of playing chess. So he used to invite many chess experts to the court to play, and one day a wise old man walked in and said, "Can we play?" And the king said, "Yes, would be very happy to play with you. But what is the reward that you expect if you win the game?" And then it's when this person says something very, very strange. He says, "Just give me one single grain of rice, one single grain of rice for the first square of the chessboard, and 2 for the second, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. So the king does a quick math and says, maybe it could be 100 bags of rice. Not more than that. There are only 64 squares in the chessboard. So they start playing the game, and the wise old man wins the game. And then the king has to now calculate exactly how much he has to give. If you can just move one slide. That's a number. If you just keep on doubling 64 times, you end up with that number. And how much is that number? If you can click once more. That's roughly 2,000 times the global production of rice. Rice produced in every single country, you put it all together, you have to wait for 2,000 years to reach that amount. But looking at the picture, it was only a single grain you started from. Fine? This is what we call as exponential. Okay. Now, friends, this story is very relevant for what we are going to do today. And in the next 2 minutes, I'll tell you why this story is relevant to each one of you here. You can just move. Same way, if I take one step, which is a big step, almost 1 meter, and I take 30 steps, I'll be 30 meters from where I started. I may not even reach the main road. But if I take 30 exponential steps, where I keep doubling, 1 meter, second step is 2 meter, 4 meter, in the same 30 steps, I would have gone around the world 25 times. Can you imagine? Going around the world, not just once or twice, 25 times. Same 30 steps. So honestly, we are not familiar with the exponential. We are so much familiar with the incremental world, the linear world. Exponential is something non-linear. Our intuition just cannot guess what kind of numbers we'll end up with. But why do you think all this is relevant today is, this is something you can all relate to. This is the Moore's law, where the computing power has been doubling every 18 months. And the cost of computing is reduced by half every 18 months. This computing power of this smartphone, if you look at 70s and early 80s, it would need a 20-storied building to house a computer with the same computing power as this. And I'm sure none of us can afford it. And today we are all able to afford it and carry it around. That is Moore's law in action, where the computing power has been doubling every 18 months and the cost is reducing by half every 18 months. This is just one technology. But if you go to my next slide, there are multiple such technologies which are getting into the electric vehicles that we are building. And some of these technologies are doubling every 18 months, some of them are doubling in 12 months, and some are doubling even in 6 months. We are already there in this stage where the technology is growing so fast and multiple technologies are coming together to enable. If I talk about an electric, connected, autonomous, and a shared vehicle, at least 6 or 7 of these technologies are going into those vehicles. So, suppose you're all familiar with the Aladdin and the G-Boomba. So if G-Boomba comes and tells you, boss, you give me a task, I will do it, then you have to give a very big, complex task to it. You cannot ask it to make coffee or get something from here and there. You should give a task which is worthy of the G-Boomba. Same way, the technology that's available to us today can do so much. that we are still thinking in an incremental way. We are looking at, can I double something? Can I triple something? Actually, we should be asking a 10x and a 100x improvement, because technology, honestly, believe me, can deliver it to you today. Because the technology is in the second half of the chessboard. The first half, it was slowly increasing. Second half, it's going to double every time. So it's really fast moving. Can move. We'll close it. We can move further. Can move further. One step back. So lithium and cobalt, what do you do with it? Cobalt is almost eliminated. Now we have good chemistry suited cobalt. But lithium, for example, Tesla has a partner called Redwood Materials, which will recycle the battery and recover 95% of all the critical materials. Lithium, nickel, manganese, you name it, it can be recovered, brought back, and put it back in the battery. So major auto OEMs will have a partner who will know how to handle these batteries and get the materials back into the system. This Redwood Materials was actually started by a former CTO of Tesla. Straubel was with Tesla as a CTO. Then he went out and started his own company, knowing the importance of this, because that's the heart of the electric car. If you can move one step, yeah. Deep sea mining. Lithium and cobalt could be scarce on the earth, but today technology allows you to mine the seas, and there are parts of the seas which are very rich in these minerals. So deep sea mining is a very, very big opportunity, and it's a very big investment for many companies to do this, and it's very economically viable also today to do deep sea mining for lithium and many of these minerals. India is looking at it seriously. In fact, Prime Minister Modi said the blue chakra in the middle of the flag is actually our ocean economy. So we are firming up policies in terms of how do we make intelligent use of ocean resources without exploiting it too much. How do you do it in a responsible way? Those kind of policies are coming up. So deep sea mining is definitely going to be an important area to look at, which will change the scenario in terms of availability of some of these critical materials. If you're a little bold, if you want to think further, there are companies which are investing on asteroid mining. Can you imagine catching hold of an asteroid and mining it? But one asteroid is enough to solve all your problems because it's entirely made of all these rare minerals. And today technology allows you to do that, and there are companies which have invested on this. So somebody will not put their money on this if it is not technically feasible. So these are things that are happening around us, whether we are aware or not. Coming back, we found lithium in India. For a long time, we didn't know that we had lithium in India, but recently it was made public that we do have lithium in India, and you know where it is. It's near the Vaishno Devi Mandir in Kashmir. Okay, and not some small amount. We have 5.9 million tons of lithium. Of course, it will take time to process it and purify it and make batteries out of it, but at least we have our own resources to start with, which puts us in a very positive mode of frame. The next is the rare earths. I don't know, do you know where the rare earth minerals goes in an electric car? Because we talked only about lithium so far. Do you have any idea? Any guess? Well, we talked about battery, isn't it? There is something else which is as important as the battery in the electric car. What is that? Motor. And the motor, if you want a compact motor, you need a very strong magnet. And that is the rare earth material. Okay. A lot of the rare earths are controlled by China. When I say lot, I would say more than 85-90% of the rare earth market is controlled by China. Primarily because Mongolia, Tibet has a lot of these rare earth reserves. So now the automotive industry is also looking at rare earth-free, magnet-free motors, induction motors-based designs and things like that, which can help us to move away from those constraints also. The last, I'll take it. Last one. So things are happening in terms of materials availability and also in terms of pricing. The cost of storing electric energy in a battery has reduced by 90% in the last 10 years. Can you imagine a 90% drop in the cost of storing energy in a battery? So things are changing very fast, primarily by the convergence of multiple technologies. The last one or two slides. Yeah. So friends, if you want to play in the automotive industry, initially till recently, it was only the first vertical, which is the typical traditional automotive industry. But today, what we call as the mobility industry is automotive plus infrastructure, because we are talking about charging, and then energy and power, because we are talking about renewable energy sources, and then the smart distribution, then the storage. So the new mobility industry is actually 3x as compared to the original automotive industry. To answer his question, how sustainable this is, if you are sustainable across all these three areas, then the electric is sustainable. If I make only my car in a sustainable way, but I don't worry about where the electricity is generated, what is being done, how the battery is made. If I have to be sustainable, I have to look at every single opportunity and innovate across all the space to make sure that at the end of the day, we are creating a sustainable mobility for the future. That's a kind of opportunity space that we are in. I think what we talked about today is, friends, in this last 15 minutes, we talked about technologies that are growing very fast, doubling in 18 months, doubling in 12 months and 6 months, and multiple such technologies coming together. So the only thing we need to do is, technology is ready to do the job, but we should give a job worthy of it. So instead of asking it to double or triple something, we should ask a 10x or a 100x improvement. That's what we call as exponential thinking. I think everything happens in our mind first, then it happens in the real world out there. So that is a fundamental shift that we need to do from incremental thinking to exponential thinking. Second is, materials will have a very important play. EV battery materials, the rare earths for the magnets, and more importantly, the electronic materials and the semiconductors, because just like our phones became smart, the cars also becoming smart. More and more electronics and more software play in the vehicles going forward. So semiconductors will have a very big role to play. So these are the materials which will really enable the cars of the future. Abundance, today we think it's constrained, some of these things are not available, but if you can expand our thinking and really look at from all the way from sea to space in terms of where we can source these materials from, then it's truly abundant. We don't have any constraints at all. And technology allows you to do all that today. Last, sustainable mobility, the convergence of industries. So your opportunity to innovate and make an impact is threefold as compared to what it was till recently. So there is every reason for all of us to figure out how we want to play in this space, what is our unique strength, how we want to enable the sustainable mobility for the future. This is a once-in-a-lifetime opportunity because many other technology waves we are lagging behind. But with this electric wave, if we do our portion of what we need to do, then the market is global. And for once, we could be global leaders in enabling a clean technology like electric. This is a real good opportunity for all of us to participate in. Thank you. Thanks, Mark. Okay. Thank you. No, பண்ணலாம்ல ஆக்சுவலா இங்க மாறி இதுனா அங்கேயும் மாறும் இல்ல நிறைய பேர் வந்து see they build their career in IC இல்லையா அதனால they are unable to let it go இல்லையா
Pretty short of time, so we will have a question section at the end. Now I request Mr. K. Chandra of Royal Enfield to give his presentation.
மைக் அங்க இருக்கு இதுவா
I have the pleasure of introducing Mr. Chandar K. He has done his BE in Industrial and Production Engineering from Bangalore University and postgraduate diploma in finance from IMT Ghaziabad. He has 3 decades with major auto components, Ashok Leyland Group, Sain Gopin, Tata Motors, Myco, Tube Investment of India, BPL Refrigeration, and significantly contributed by driving quality system and process towards the excellent. He is with Royal Enfield since 2017 and evolved quality management system for 3 years to realize the goal of customer satisfaction, number 1 across the organization, and implement company-wide quality through global benchmarking on process system. At present, he is head of corporate SQA and for 3 years marching towards goal of less than 100 ppm in 2 years. Over to Mr. Chandar.
Okay. Before the slides comes up, I should thank the Indian Rubber Institute and Mr. Janakar for giving me this opportunity today. And I also have a disclaimer here before I start. Unlike the previous 2 gentlemen who spoke about the technology, I am not a rubber expert. I am not a polymer qualified person. So, and I should thank them, in fact, to make my presentation easier and connected to what they have already spoken about. And what I'll be talking about is how MSME will be moving towards digitization, because that's what we all are in the life today. And we know what is digitization happening in the country as well as in the globe, as Shankar was just explaining on the connected vehicles and technology which is coming up. So we all know digitization today, in fact the last decade, what's happening in our own country. Like we all stopped using the wallets, the cards, the credit cards, and today everything is on the smaller, which you carry on your packet, which is just a mobile, and everything is digital today. So that is what is driving us. And with that background, I would like to take you through what I have put in place, what will be required from the industry, from the OEM, as well as with the MSME, and more to do with the polymer industry, where we need to have a lot of things which digitization will help in getting things connected. That's okay. And that's another problem with digitalization also. That's okay, I can manage. Just more than next. So we just spoke about what is digitalization, and this is what we will all be facing, and we'll have to upgrade ourselves, because we have no other option other than getting ourselves equipped and also learn more, unlearn, relearn. That's what we are going to be, all of us. So one thing which I was just telling my friends here is, after seeing the team here, I thought I am pretty much older because this generation, what we were from and what the generation is here today, because I'm not able to operate whatever is there in my mobile completely. And I have two daughters, so they handle it so very professional that as if they have been qualified to use that. So that's why I said we have to unlearn, relearn, and also get equipped day by day. It's not that we just do it today, it doesn't end. Yeah, that's a valid point. So we just step back and just see what was industry moving in the last 2 centuries at least. So we are today in industry 4.0, but it was 1780s where the industry first revolution started, just mostly on mechanization, where we had the steam engines and the locomotives coming up. And then 70 years later or 100 years later, we have this mass production assembly line, electrical energy coming up. So industry 3.0, we have this computer generation which has started. If you see the timeline, it's almost every 100 years there's a revolution coming up, but it's not going to be so moving forward after industry 4.0. As Shankar was explaining, it's going to be X times. It's not going to be incremental. It's going to be exponential. It's going to be minute after minute. It's not going to be on day by day. That's the industry 4 after. It's going to be like that. Next slide. So, what is industry 4.0? I think most of them was touched upon, but I'll just look at a couple of things here. In Internet of Things, which is happening today, and system integration. These two are very much interlinked, and a lot of things are going on the simulation studies, which where earlier we had to do the parts by hand, and today we have this additive manufacturing. You just give the program, you get a 3D printed part in a couple of minutes. And in fact, the technology is so that in civil engineering, just to give a background, there are houses being built in China within a day. And it's not just one house, it's a multi-storied apartment. Cloud computing, this is something, augmented reality, which is becoming a big influencer today with all this big data information. So what is augmented reality? We were used to virtual reality, but now everything is, for example, you search anything in Amazon, you want to buy a TV, I'm sure you would have done that. You just can place the TV wherever you want to locate it. So it gives you the clear information to you that how, where you want to place it, and then you can go ahead on the order. Yeah, next. So, just to give a background, what is digitalization, and this transformation. So today, this everyone knows what is it. It's all about your paperless and going into documentation and business use computers, tabs. This is what is digitalization. But this is what will be the future. If everything is connected, synergy between, synchronization between all your systems, all your processes, all your database, now that will be the digital transformation. One point which even Mr. Shankar was talking about, it's about connected vehicles, which as Royal Enfield also we are getting into this connected bikes. Today we have a navigation device, and also we have a instrument cluster which gets into all this data which gets connected. And connected bikes, we have an app which is into the any bike you buy recently, which you have bought anything, we have this connected bike system like other passenger cars have, Honda or Mahindra has that. So what helps there is we are trying to get into the engine performance system. Like in case of today, if there is a problem, you come to know once it stops, right? But what will be the future is this connected bike system or the connected vehicle system will give information to the person that at this kilometer you will have a problem. If you are having any difference in your rideability. So that's how the system is coming up and the technology is building. Just to give one example, which I was learning a while ago, this is on the commercial vehicle again with ZF transmission system. This is in the Europe. So what was done there is like they had a chip inserted into the transmission system, and what does that do is it gives feedback every hour. So it gives feedback to 3 places. The first thing, it gives it to the driver, so he knows at what speed he's driving. I mean, that anyway he can see the cluster and get it done, but still what it gets information to the driver is he is braking so many times, and he is also using the steering system in this manner. And the second information which goes to the fleet owner, that this particular driver is the way he is driving, and his performance goes to the fleet owner. And the third important thing goes to the manufacturer. So he comes to know that this particular transmission system, its performance is such that, so when it will have a service interval, and what date or what time it will have a failure, and what part which can go into the service. So that's the level of technology which is in place today, which will come up in all our, including all the passenger cars and commercial vehicles in India. So just to give a back information on what is happening on the economy today, this is what it is. So we all think we lose jobs if it is digital, and there will be a lot of people who will not have jobs if a lot of things get digitized, but it's not so. It will create a lot of opportunities to the next generation to have a lot of inputs which they need to think and then give to the system. Only a human can think beyond and give information to the instrument or the technology. It's not that technology cannot think for a human. So let me make it clear, it's not that we will lose jobs. Today, just one. So today we all know this is happening. Digital delivery of goods and services, which is we all every anything, whether you want food, grocery, medicines, anything and everything is available on digital platform. We don't even step out of the house. The best example was, and this all came up in the last 3 years, thanks to COVID. We developed all this technology because of we were not able to do something like this. This technology has been evolved in the last 3 years to such an extent that we don't step out of the house. We get everything at the doorstep. So, what are the 4 types of data analysis? Descriptive, diagnostic, predictive. Now, we are here. When we say we are, at the OEM level or the companies which are IT enabled companies, right? But this team sitting here, we would like to have you also along with us when we move towards predictive and prescriptive analysis. So what is predictive, prescriptive? Maybe you can Google it, you can always get that. But here, as I was saying, this ZF example is the best thing where you get predictive and Prescriptive is you need not go to the service station for any problem. They will call you, they will come, or today everything is on wheels. They come down and then they do this service, and then they have the prescription for you. How do you use the bike or use the car or use the fleet? And that is what will help us in terms of this sort of data analysis. Now, why I am saying this is for this small and medium scale industries, we go more on documentation. That's because two things. One is the certification body is asking for that. Second is your own managers or the supervisors ask for that. Now, if you get into this data, which is, if it is can be digitized, now how it will enable us is in terms of your analytical capability. See, today what we do is we start recording and then we either use a computer or an Excel sheet or something. We try to do that, and then so what happens there is the time and effort. This is too much for us to get into because today's deliverables are not like what was yesterday. Now the customer also wants a product which has to be delivered in the next 2 hours or 2 days. That's how it is. So why I am saying this is the data which you will have in abundance needs to be completely transformed into a digital platform. Two ways of looking at that. One is your own team can do a better diagnostics, and the customer need not wait for your inputs, so he can also get this online, and that is all possible today because this is one example which or one such we have also been implementing with most of our special process team, which includes rubber also. I'll just give one good example where we have done this on a surface treatment industry. They have this SCADA based controls. So what we have done there is with this SCADA based, we have everything online. And what is being done is we take it to the cloud, and if something goes wrong on a special process, it's going to be the patch which is going to be affected. It's not that one or two pieces will get a defect. So with getting into the SCADA online, what helps there is the plant manager and the owner gets a signal immediately. It's all through an app. So he comes to know immediately that something is wrong. And today, if something is wrong, we all try to deviate. That's because there's nothing wrong with us. It's because that's how the business runs. So what happens there is automatically it stops. Unless until the supervisor or the person in charge there goes there, corrects it, and then moves on. Now this has been done with many of our surface treatment suppliers, and which has helped us to improve this 10x. Just to give a number, we were at about, I'm talking about the hardware industries, where we get defects in millions, it's not one or two. Either a hydrogen debrittlement problem or a surface treatment, not having a low plating thickness. In fact, we had this in the rubber industry also, low hardness, shore hardness, all those things we keep getting. So what has happened is we were at about 2000, 3000 ppm, which has now come down to 70. That's the ability of digitization which helps. Now, why I am saying all these things to this group here is the MSME, specifically rubber, which I'll also touch upon in the latest. What is that we are also looking at and expected from this team. So, as a country, we benefit. It's not that you benefit or I benefit. As a company, as an organization, as an industry, and as a nationwide, we get this benefit in terms of time, cost, effort, finally the business. This is exactly what I was saying. So if you look at this is business to government interaction, you see the percentage of adherence there. Because we have no other option today. Without GST, you can't bill anything. So that's almost 100% in the business to government interaction, where you keep seeing this on the, this is the larger, the outer one is the large scale, and look at the small scale, which is the inside one. Again, you see here, business to government on the small scale is also almost 90%. But then, engagement, I mean, this is again on your network, and as I was talking about the online informations, e-commerce, cloud computing, this is where we need to focus. Now this, if it improves and matches, why the large organizations able to do? It's again, one is the investment of course, but you see the benefit of that doing one time. Just to give an example again, the GST, earlier the sales tax, each state had a different tax, and you know what is the level of the cost or the benefit which the government is getting, all of you know, right? So it's like 200,000 crores a month. It's like 2 lakh crores. Earlier it was not that much. It was not even 10% of that. So, this is what I was talking about, expectations and benefits of a rubber component manufacturer. So, online process controls, it helps in this. In fact, some of them have this automated mixing. I've seen that in high-tech IRI, Fener also. So, it's completely automated. So, there is nothing like you can make a mistake there, unless until you are forced to, which nobody wants to do. And molding, post-molding, I think you're also touching upon that, the post-molding operations, cryogenic. So that's something where it's not that everybody has to move towards a cryogenic, but it has to be automated. So what helps us is the flash. Now, the flash, we think this as a flash, but it can create a complete havoc into the engine if it gets into the engine system. It can create so many things as a problem because of high carbon content, and also the flash which gets into the, today there are a lot of things on the emission norms, BS6, which is so very stringent that even a small amount of a rubber flash can create a problem into the CAT emissions. This is something which we all have to get into, because today in our engine, I'm talking about Royal Enfield, the engine level, there was one survey done by a third party in Europe. This is about a couple of years ago. He took all the big OEMs of two-wheeler two-wheeler manufacturers and took a study on the engine quality. What he did, he just drained the oil and just compared the level of contamination, and we all know what is millibore value. And we were also surprised that Royal Enfield was the best, cleanest engine amongst Triumph, Harley, BSA, who is there in the Ducati. So Royal Enfield was the best, cleanest engine. Now, how could we do that with this? We take all the critical parts, do a washing, whether it's a gear or a shaft or things. That's how we started doing. In that learning, we are now getting into the rubber parts. This has now become the norms for us. We already started getting into the O-rings and things where we want it to be less than 5 mg. That's the level of cleanliness we expect from your processes. It's not that you're going to pack it, clean it and give, it should come from your molding process. So that's the expectation what we also have. Most important, we call something as agreement of inspection, right, between the OEM and the supplier. But what happens there? It's just on paper. It's not just an agreement of inspection, it's an agreement of measurement techniques, the test standards. It's not only with the rubber industry, it's also with our other proprietary, so-called proprietary. We give them test standards, but the way they do the testing and what we do the testing is entirely different. And so what we are now initiated in the last 2 years is to have a test method, test procedure, test equipment, and also the test cycles. We are standardizing that and then getting into those sort of initiatives. This is something where rubber, because you can't measure rubber in a vernier, so you need to have the specific equipment. So that's where we all have this gaps in terms of understanding. So this is what I touched upon, AI-based visual inspection. Now, auto sorting. When I say auto sorting, you can have cameras, you can have many things in place as an AI system, but what will or what can go wrong is your ability to bifurcate between the good and the bad. Unless until you have automated sorting systems, it's not going to be that easy. And it's definitely not easy for a rubber because it all depends on the size and the thing and the people. Mostly it will be what I have seen is women employees who do this inspection. Why do we employ women is, one is their ability to do it better than what we can, and of course they are well, I would say concentration wise and things they are better than us in terms of doing the task, right? So, but then again, whatever you do, there is a problem which can happen. So when it gets into FMEA, we try to eliminate the potential failure modes. One is this auto sorting of defectives. This is again to eliminate the human error. Another most important topic is on the tooling management, which most of the rubber polymer is multi-cavity tools, and traceability. Traceability is something which is a big subject which we are also getting into the QR code. So you have exact traceability of when it was produced and what date and what time it was produced, and specifically going to the tooling management. If you have this SAP controlled, when I say SAP or whatever system you have, so you need not monitor everything on a paper, which is again, we just do it for the sake of doing it. Let's not do it for just to create records. We should be able to monitor it by an automated system, which helps us to not only have the information on number of pieces per cavity, we also know the estimated life, also the actual life, which is coming through the system itself. So, I think given Dr. Nair was talking about this traceability, we need to have part level traceability. There is one law which is already in place, most of us may not know. There is a recall system which is already in place in this country. And can anybody guess what, if you don't give a batch traceability, what could be the consequence? Any guess? I hope you understand my question. See, if there is a problem, they say from 2018 to 2019 March, from April to March, something like that. They just, if any recall, if you read through the news, it gives a period. In that period, if something goes wrong, is what those number of bikes or those number of vehicles are recalled. If that is not available, you know what is the consequence? No, the consequence to the business. 7 years of recall. 7 years of the part which was produced till the date of the problem, everything has to be recalled. Now that is eating away our business, shutting down. And this happened with a company in Japan. I'm not sure how many of you know Toyota. Sorry, no. Takata. Not Toyota, sorry. They make this airbags. Yeah, they had to shut down their business almost 7 years of recall they had to do. Airbags had a serious problem in the US. And just to give an information, we also started CKD businesses across other countries. We are also into the Americas, North America, South America, Thailand. We recently started in Nepal, Bangladesh. The reason for telling all these things is in the US, the rules are very, very stringent. The National Highway Transport Authority in the US, how they look at things is any problem across the globe, if you are selling it into the US and if you are selling it across the globe, any problem, and suppose you get something in Japan or Korea or Thailand, and if that problem is, when that bike is also sold in the US, you need to communicate to them. That's how stringent their norms are. And this is something which all of us should know, because as Pradeep was also saying, we need to have a lot of things getting Atmanirbhar, make in India, and also ensure that we also are present globally. So if you have to be present globally, these are some things which we need to know. And to need to know all those things, we should be getting into the digital platform. And if you get into the digital platform, it benefits you all, we all, and as a nation, as I was saying. So, last but not the least, this is, I've just written it in one line, but it's almost a subject where you can keep talking and talking and talking, and it's not just talking, we need to practice. So when we say green packing, we don't want to use plastics, we don't want to use metal, we don't want to use wood, we don't want to use something which is heavy, and we don't want to spoil the environment also. So which is another initiative we have taken up, and we have gone multiple times better than what we were 5 years ago. So this sustainability in terms of solar, which I think Pradeep was also talking about, solar cells, solar roofing, natural lighting. In fact, our headquarters in Sholinganallur recently got certified for this green building, which is something where we are also proud of, because we are also giving it back to the earth. And we are carbon positive, water positive, carbon negative, water positive, and we also have a lot of green, that is, we call it as Miyawaki implementation, which is nothing but having so much amount of green footage into our own campuses. So these things will help in terms of giving it back to the earth. One of the vision what we have is how much we give back to the earth in terms of whether it is use of plastic, use of saving water, saving energy. Right? We have a tagline called "Leaving the Earth, Place Earth Better." This is something which we follow. And that's the reason we always have, whenever we go for a ride, whether it is the Himalayas or into the other areas, we always have a group of team which is going, and then we ensure that the place is always clean, the place is always green, it is always better than what it was. It's not that we go spoil it and come back. Because the emission, one is the BS6 itself is giving us a better emission norms, but we also want to have as a company, we want to have this place better than to live for the future generations to come. Just click on that video, that link. Just go back. Back. This link. I just have 1 minute video. You're not able to? No, it will come on the screen, sir. Okay, it's fine. So that was actually the video was basically about the digitization, what the industry is going around. It's just about a 1 minute video to show where the industry-wide digitization is happening. It's okay, sir. No, it's not. That's okay. So that's all I had. So basically, the message is as they were talking about technology and innovation and connectivity and all those things, this helps. Digitization helps us to get into all these things and in terms of improving your business, improving your process. Yeah. Sound? Yeah. Thank you. I'll just end with this video. Thank you. Thank you.
Thank you very much. It was very, very informative. And of course, whatever the great presentation also was very informative. Only thing is, we are very short of time. All I would request is, I would like the speakers to request if there is a specific request from the audience, the participant, to please allow us to circulate your presentation matter. Now, I request Mr. Ganesh Sundaresan of the Home Water India to make a presentation. Take the so after we consider, he will make the introduction.
Good evening. Thank you to for attending this seminar. Now I introduce Mr. Ganesh Sundaresan. He's a DGM in Yamaha Motors. He had a 20 plus experience. He started with his basically a mechanical engineer, started with supply chain, and worked in various automobile industries like Renault, Ashok Leyland, and Yamaha also. And finally, he is working in Yamaha Motors from 2014. He is in charge of 2MS in the Yamaha Motors. He is in charge for the quality planning and assurance, and he's a lead auditor also in for ISO 9000 and certified trainer for AM PQP in Renault Nissan and certified trainer for TQM daily management. So I welcome Mr. Ganesh Sundaresan to give his part in this lecture. Thank you.
Good afternoon, all. Speakers before me, Mr. Pradeep, Dr. Shankar, and also Mr. Chandar. They have touched upon a wide range of topics, which I think you felt more relevant. Like Mr. Pradeep talked about the technical challenges in rubbers and polymers. And Dr. Shankar gave a lot of insights towards EV, emerging EV trends. And Mr. Chandar from Royal Enfield, he touched you upon on digitalization, which we are coming to terms with. So I have to say I am not expert in rubber technologies. EV is also a fairly unfamiliar topic for me. So today I have to say I also learned quite a few things based on the explanation from the speakers and based on also your interaction. So this session has been quite useful for me. And talking about my content, I will keep it short, of course. Last 3 or 4 years in Yamaha, we have been working towards strengthening the regulation quality assurance, which means like understanding the various regulations, that is law of the land, not only about India but also globally, about global markets. So I am sure some of these information will also be useful for you. May not be totally new for you, I guess, but surely I think this will be useful for you in trying to sensitize this topic in your organization. So my final objective of sharing this is to basically sensitize this topic about regulations. That is, as I mentioned here, the growing importance of complying to regulations. As you all can relate that compliance to regulation is a kind of make or break topic. Meaning when we follow compliance, we may not have big benefits, but if we do not follow compliance, we will have a heavy loss. So on that note, I will keep it simple. We will share the background. All of us, I think, are well aware of the background. And I will share some of the trends that are happening in the market. Mostly I will try to keep it relevant to the audience here. We can move to. So this all of us know, this is nothing new, I guess. There has been some policies which has been actively promoted by the government of India. Some of the speakers today also talked about it. Let's say like Make in India, which has been there from 2014. And we have Atmanirbhar Bharat, which started at the time of COVID. And many of us have been hearing slogans like vocal for local. and also make for the world. Such slogans have been very prevalent throughout the last several years. So the summary of these policies, if we see, they have simply two objectives. To put it very simply, of course, there are several intentions and objectives. So one is to increase the export, and second is to cut down the import. Simply speaking, these are the two very key objectives of policies like Make in India. Make in India is to attract the foreign direct investment. And Atmanirbhar Bharat, I am also a native Tamil speaker, so it is nothing but self-reliant, making our nation reliant on ourselves. So with that, I would also like to say, when we say as a nation we are trying to increase the export, so in the context of today's session, what it means to us. Because export is generally conceived as a good. More export we do, the more profit we get. On the other hand, if you see, when we talk about export, it also comes with several newness, meaning several new things to our business, which is also on the in terms of risk. When we have a newness, it's a risk for us. It's an unfamiliar zone for us, where we do not know several things. What are these newness, basically? These are some examples I tried to provide here. For example, here several speakers talked about exporting to Europe, exporting to US, exporting to Oceania regions. Basically, all these markets have new users. They are not the users same as what we have in India. So technically, Indian users are totally different from the users of Europe. They have a different feeling. They have a totally different perception of our product. They have a totally different expectations. And the worst case is, it is different in different destinations. It is not that India and outside India. It is India, US, Europe, Oceania, Asian region, African region. So every destination has their own expectations. The environment is different. So in our experience, talking about the rubber industry here, the rubber had a major failure due to cold environment, which we are not used to in India. Extremely cold environment. And application is different. We know several different way of usage of our product, not simply a passenger vehicle. Some countries use a passenger vehicle with body. Some countries use a helmet holder at the back. Like Europe uses two-wheeler with a helmet holder. And the last and the key focus I want to emphasize here is, every destination has a new and different regulation. And compliance to this regulation becomes even more important. So when we talk about export, of course there are several aspects. And in today's meeting, I want to focus on new regulations. So when we talk about export, we also have to sensitize our team members about complying to those regulations. Next please. Right now, about global market, when we say regulations, sorry, these are two different colors. If you see, this is North America, and we have also European region, and we have Oceania region and Japan. So these countries have already a very stricter regulations, like Mr. Chandar talked about a very stricter safety laws in United States. Similarly, Europe too has a very stricter law for safety, and even more a stricter law for what is called hazardous substances. Japan has a very stricter law for things like inspectors, vehicle inspectors, qualification, and so on. So such countries have a really very stricter regulations. On the other hand, there are countries like Latin America. We have ASEAN region somewhere in the middle, and we have China. So such countries, although today they don't have very strict regulations, but the trend shows that they are coming up with a lot of regulations. So by taking cue from stricter countries like Europe and US, other nations also, where India predominantly have business with, like Latin America, ASEAN, they are also coming up with more stricter and stricter regulations. So today we don't know so much about Africa and Gulf, but I'm sure they also are going to follow the course about adopting more and more regulations. Right, Russia of course is kind of black box for me, so you don't know so much about Russia. So if you see all nations in the map, or either already have some very strict regulations or going to adopt stricter regulations. It is a point of interest when we talk about export business. Next. I would like to give a typical example of regulation. When we say very strict, so in the context of today's audience, I want to give a typical example. I'm sure many of us here are familiar with topic of hazardous substance. So if you see, as I said, across the world, currently as we stand today, European Union has a very strong law for hazardous substance, what we call REACH. It is a kind of like 800-page standard with several chemicals, so many chemicals listed on that. I'm sure even chemicals used in rubber industries are also part of it. And each chemical is given a limit beyond which the manufacturer is not supposed to exceed. So limits are set by the government, chemical-wise, in terms of percentage use in your product. Now Europe already has this, but if we see across the world, in recent years, US has already started adopting many of such regulations. Canada has started adopting, and not only that, every now and then a new chemical is emerging. Example, France, they already are restricting something like a mineral oil. From 2023 and again from 2025 they are with a modified limit they are restricting. Right? Talk about mineral oil, it's targeted in printed items, all printed items. Similarly, microplastics. Europe is regulating microplastics, which are targeted in items that have exposure to rubber. It could be, some of your products could be the target of this, since some rubber parts are also having exposure to the UV light, sunlight. So key point is when we look at the global markets, there are several emerging regulation trends, like Europe is putting, like Mr. Chandra talked about digitalization. So Europe is coming up with a lot of cyber security related regulations. Lot of radio equipment devices related regulations. Cars started using many electronic devices, so regulations like radio equipment devices, cyber security requirements are coming up. And for this audience, I think more relevant is hazardous substance control. So we really have to take it very seriously. There has been also a discussion about recycling by Mr. Pradeep also, by Mr. Dr. Shankar also. Right. Europe is coming up with many recycling targets, and I'm sure many of you know India is also adopting a regulation. Draft has been already released. End of life vehicle regulation is already drafted. Sooner or later, it's going to come, including the recycling targets. Next. Now that was about global market. When we talk about the Indian market, right? As I said, Atmanirbhar Bharat. This is more about cutting down the imports. Right. On the other hand, cutting down imports have own challenges. When I talk from vehicle manufacturer point of view, when we say cut down the imports, this has their own challenges. Like I think Pradeep shared that out of many rubber raw materials, we are importing from several countries like US, China, so on and so forth. So which means today the capability in the market may not be there, capacity may not be there, and in some cases importing currently is cheaper than doing it locally. So such challenges are there for vehicle manufacturers in cutting down imports. Right? Challenges are challenges, but Indian government are also coming up with a way to tackle such challenges, which I will explain next. So I guess we have some members from DPIT oriented company like Mr. Paul. Right, this example I am giving of DPIT. DPIT is Department for Promotion of Industry and Internal Trade. Some of you might have already heard about this. This comes under the Ministry of Commerce and Industry. If you see the last, this picture has been extracted from DPIT website. DPIT has been promoting very aggressively to cut down the imports. Very aggressively. This means also the opportunity for MSMEs. When I talk about the challenges for OEMs, on the other hand, these are also very good opportunities for MSMEs. Just about several items are coming in the ambit of BAS license, what we call a BAS license. IS standards are getting issued by BAS. BAS is issuing IS standards for various items. Few months back, we would not believe even hexagonal head bolt, hexagonal head nuts. They have been brought under the ambit of BAS license. Meaning manufacturers, either MSMEs or vehicle manufacturers, we cannot use any hexagonal head bolt or hexagonal head nut without obtaining a BAS license. Right, such is the direction that the regulation trends are progressing. You can get a sense from this picture. There are several items. I'm sure some of them will be part of rubber industry too. Like recently, V-belt. V-belt used in automotives like scooters has come under the BAS ambit. Wires are coming under the BAS ambit. There are several things, and this is not going to end here. Several items are in the pipeline, already in the pipeline. I have participated in some discussions where DPIT interacts with manufacturers through CM and also through ACMA. The message is very clear from DPIT that please go local. So they want vehicle manufacturers to take local suppliers by default. So worst case scenario, go for global suppliers. This has been the policy and direction of DPIT. And the key point is such BAS license, the process is very critical for import. And the vehicle manufacturers more and more are bound to have a transition from import part to local part. Surely our expectation going by this regulation trend is many manufacturers are going to approach for local manufacturing, right? So this is my final page, a summary of what we have been discussing, that the manufacturers like us going to really expand our base, and in this scenario we think compliance to regulation will play a very important role in doing a business. We manufacturers treat compliance very strictly, whether it's Indian market compliance or global market compliance. And it is right time that we have to sensitize this topic of complying to regulation. And compliance means it is not only by incorporating in our product and process, and that is first and most important step. If we have an hazardous substance, it's important to engineer and find out a substance that is hazard free. So that is the most important step for experts, technical experts like you. But not only that, we have to also build a strong management process to continue to comply during our mass production stage by building a strong HRT department. So I am sure together we will make a very strong product with good quality and also with strong compliance. Thank you. This is from my side. Thank you.
Thank you very much for your presentation. Now, I request on MSME sector, Mr. Karthik, to come. Please introduce.
Yeah. So we heard from one side of the oil manufacturers giving what they need and what we have to do the rubber industry. Now, that will not be finished our seminar. So we want to take the voices from the other side. So we have taken the persons from the rubber industry. He is Mr. Karthik. He is the vice chairman for the All India Rubber Manufacturers Association, and he is running a factory. And he is a partner in the Sri Polymers, who are manufacturing technical rubber products. So we want to hear from voice from his side to the oil manufacturers, so that will fulfill our seminar. Thank you.
Good evening, everybody. So very happy to be here. Thank you, Mr. Janakar, for inviting me over here. I'm Karthik from Sri Polymer Products. I'm a partner at Sri Polymer Products, and I'm also vice chairman at the All India Rubber Industries Association. So I was wondering, in a room full of technologists, what is a business person like me going to talk about? But nevertheless, I thought I'll give it a go. So we are supposed to be in the fastest growing economy right now. So can I just take a poll? Does it feel like we are in the fastest growing economy? Are we having that level of business and new product developments coming in?
We are in the fastest growing. Yes.
All right. Thank you. Next slide. So to start with, I'll just speak about All India Rubber Industries Association. It's a non-profit body serving the rubber industry and with objectives of safeguarding and promoting the interests of the industry. We are the largest umbrella organization for the rubber industry, and all across India we have more than 1,500 members. We have 4 regional offices in North, South, East and West, and I work here in it's an honorary position at the Chennai office. Next slide. So we work on policy advocacy for the rubber industry with both state and central governments. So we work on things like anti-dumping duty and trying to bring, give the industry perspective on rubber policy and so on and so forth. We also conduct various technical events like the National Rubber Conference. I'm sure most of you here would have attended, and various other trainings, and of course we have our India Rubber Expo, which concluded very recently, and it was well received. I think it is the biggest event for the rubber industry here in India. We also have a library with a repository of various technical documents for reference. Previously. Yeah. So coming to the topic at hand, we are here to talk about how technology can potentially transform the MSME industry. So what is the MSME industry? This is how the government of India classifies it. Any industry which is with an investment of less than 1 crore and a turnover of 5 crores is called micro, and then 10 and 50 is small, 50 and 250 is medium, and anything above that is large. Beyond which, the typical workforce size would be probably 15 and 200 and 600 and probably 2,500 or more in larger industries. And micro industries would probably do works like job working, mixing, just molding with 1 or 2 presses, turning, plating, and manufacture of subcomponents. Whereas, small industries would be manufacturing components and sub-assemblies. Medium would probably be doing assemblies and products, and large would be working on products and platforms. So this is just an overview, and it's not a strict delineation per se. As far as capabilities are concerned, I have left out investment capability and technology access out of this. Because with capital investment comes technology access. Today, everybody can go to an expo, can go to China, can go to Europe and get access to technology. And if you have money, you will get access to technology. But the other things which critically differentiate micro, small, medium and large is measurement capability. Typically when we see people produce products, but they do not invest on measuring the part to understand whether they're given a right part or not. And testing of parts in terms of lab testing and field testing, design capability, and then market reach. So why are we talking about all these things? The primary reason why we are talking about all these things is doing businesses like, holding a tiger's tail. Typically, so if you are in micro, you are as good as a self-employed person. Okay, so you do something, you take home some money, and it keeps going on. And the day you retire, the whole thing shuts down. But once you get into a small level, you have to keep running. And then when you get to the medium level, and then you go on to the large level. So what are the typical, critical differentiators between the different levels is what I wanted to showcase. And how technology will help us move from one level to the other. Next slide. So the typical ARA membership demography is like this. About 10% of our members are large industries, and 20% are medium, 50% are small, and about 10% are micro. So this is the typical demography of our industry per se, and most of us are in the small segment. So how do we graduate and move to the medium segment is what we are all trying to achieve. So the importance of MSME. MSMEs form the essential building blocks of manufacturing ecosystem. So when we say ecosystem, if there is just one big company, say, if I have to give an example, once Kia set up its plant in Anandpur, they had a lot of difficulty running the plant. So you need people at every level, at the medium level, at the small level, at the micro level, to support your entire endeavor. If I have to go and get a mold made, a mold fixed, a jig made, a fixture made, anything molded or anything of that sort, I should be able to go within a very short period of time, and I should be able to achieve that. So that ecosystem, that anchor is given by the MSME, and it's not for the larger industries. So without the MSME, the larger industries will find it very difficult to sustain their operations. And it is the true employment generator. So for every crore of investment that is made by a large company, vis-a-vis the investment made by a micro or small company, we generate anywhere between 10 to 20 times the employment. So, and today, as per Udyam website, about 12 crore people are employed in the MSME sector. So this is the anchor that helps in social mobility also. And it's also an incubator for talent and entrepreneurship. So I'm sure a lot of you sitting here would have worked in some MSME and then probably moved on to bigger corporations. And so it's a hotbed of talent. And it's also a hotbed of entrepreneurship. So we teach other people how to go and hold the tiger's tail so that they can start running along with us. So transformation through technology. So actually initially when I started making this presentation, and I was sitting here and I realized that my presentation is almost in the same line as Mr. Chandar's. So then, but luckily I think I've taken a slightly different route to it. So which are the vectors of transformation? Typically it's the 4M and 1E. So you have material, machine, man, human resources better, and method and environment. So in this, I wouldn't like to talk about material to a bunch of technologists or machines. So we've seen all of that in the India Rubber Expo just a couple of weeks back, and to our heart's fill. There are enough materials, new age materials that are coming in. And I would like to assure Mr. Ganesh that the Indian industry can produce any part. We are competent enough to produce any part of any specification that you require. All we need is the opportunity and the trust from you.
Opportunity and scale also.
Yes, scale also. Yes. Yes. So when we talk about scale, here the top line for a small industry is 50 crores. But when you go to Europe, the top line for a small industry is 10 million euros. So there is no comparison of where we are. And typically when people come from other countries and talk to us, what we feel is that the scale is not there. India, things are there. People, there are very good industries, very niche companies making excellent products, good technologies. We have an engineering thought process. We have an honesty towards our approach to making products, but the scale is not there. So I think with the efforts of the current government, we hopefully we will achieve that scale. So I don't want to talk about material. I do not want to talk about machine. Machine, though, there is enough and more that we have seen. Everybody knows about cryogenic deflashing. Everybody knows about auto sorter. So it's all done and dusted. So there is, and rubber molding is not something which was discovered today. It has been happening for the last 100 years probably. So the other key aspects. So next slide. So I'll start with environment. There was a time when, a rubber factory used to look all black and smelly and, things like that. I think now we can say with pride that a lot of companies have transitioned from that kind of a thought process and have made it a nice, clean and more vibrant workplace. Where, there is an aspiration for young people, engineers and workers and people of all levels to come and work. So especially, when we talk about GADSL and REACH compliance requirements, when we start bringing all that into our shop floor, what happens is people lead more healthy lives. Ultimately the rubber part has to be produced. But how to make it best possible, how to do it in the best possible way for the customer, for the environment and for the people who are working to create the part. So this is the endeavor. And as Mr. Ganesh was saying, we are already, on track on, various companies. are already on track in terms of REACH compliance and GADSL compliance. So in our National Rubber Conference, we have many papers explaining about all these things multiple times so that people get on track to all those things. And also, apart from a happy workplace, we also need a happy world. So we need methodologies wherein you have a clean working environment. We don't spoil the environment by producing our parts. Of course, we will also require the help of the government and institutions like IRI, wherein which help us in understanding how to do a clean disposal of unused chemicals, how to do a clean disposal of unused products. So this is I'm sure it's a challenge in many companies which needs to be addressed. And going forward, I hope all the stakeholders will come together and do something about it. The other thing is method or know-how. So as far as method or know-how is concerned, our working pattern and working style creates our know-how. That apart, the machines are the same. What machines are there in my company, I'm sure are there in most companies. What materials I use are there in most other companies. But really, how we go about manufacturing the product, the process definition is very key in creating the best possible product. So, as technologists, that is an area where your inputs are very important. How do we handle materials? How do we ensure that the inconsistencies are reduced, and so on and so forth? So, defining the methodology in entirety and creating an organizational intelligence. When in an entrepreneur-run institution, the moment the entrepreneur leaves, it does not mean that all the intelligence leaves along with the entrepreneur. The organization itself has an intelligence. The people there understand how to work. They know how exactly they have to go about their daily activities of production or sales or storage or so on and so forth. So how to build that organizational intelligence is very important. The other important thing is capacity utilization. Typically, capacity utilization is a big bottleneck. When we actually calculate our OEE and capacity utilization, in a very scientific way, it far is lesser than what we would typically think from a common sense point of view or just from a general overview. So that is again one area where a lot of focus is required. The other is, of course, 3D modeling and 3D simulation are new areas which require, where everybody can get onto those kinds of software platforms to fully model the products that they manufacture, fully model the molds that they use to manufacture, fully model the entire process of manufacturing. So how the mold opens, how the part is released. So all these things can be modeled in 3D environments today. And that apart, the product simulation can also be done. Performance simulation from a micro level to a part level can be done completely and checked for sufficiency. Last but not the least, of course, HR is the lifeblood of any organization. Human resource is probably the most important resource in an organization. So, if a machine could do what men could do, then I'm sure none of us would have a job. There are enough people with a lot of dollars, they'll buy the machines, put it and switch it on and it will punch out all the products. The real thing that makes the products are the people who are handling the machines, who are working with the materials. So how best to leverage their capabilities is very important in MSME transformation. So, but out of all these things, the most important vector which I had kept for the last is information, which is what Mr. Chandar was also talking about. So the real way for transformation, the real change that probably India is going through right now is because of rapid adoption of digital technologies. And I think that is something which we need to do in all our shop floors also. So just to give an outline. So all these capabilities that I had outlined is a matter of information gathering and information analysis and usage. Measurement is a form of information gathering. Testing is information gathering and usage to build a better part. Design of products is also completely all model based out of information, and market reach is again where to go, whom to sell to, what price to sell at, how to sell, how to reach the product there. So information plays a very key and critical role in the whole product life cycle, product development life cycle. So various areas of information capture is, IT adoption is data capture, getting actionable information out of the data analysis, and using digital controls for process and product quality assurances. Next slide. So types of data would be general business documentation like RFQs, proposals, various QMS related documentation, so on and so forth. And you have accounting, finance, and statutory and regulatory data. Then of course you have inventory data and process records, process control master data, and process and life cycle, product and process life cycle information. So I think product and process life cycle information is very key. Right now we have various standards like CQI 30 that has come out, which has probably some 600 checkpoints. So if anybody is here who can guide me on how to go about achieving all the 600 checkpoints, I would like to learn for sure. But it's a real extraordinary undertaking that which we have to go through to really achieve that level of compliance and that level of sophistication in operations. And data capture and data analysis is everything about it. All CQI 30 talks about how many times you rewarm your compound and what temperature you put it inside at, what temperature you got it out at, and so on and so forth. So these are very extraordinary requirements which will flow down to all automotive manufacturers going forward. So it's just a matter of time. If somebody has not touched it, it is going to come and touch you very shortly. So please, bear that in mind. So I've just outlined a very basic data capture progression. Say for a micro company which has literally nothing. Where can they start with data capture? They can start process data capture from simple things like, put a timer to, control your cycle time or understand, how the process is moving forward. Then you have a simple mold auto temperature controller which can maintain the temperature of the mold or the oven. I'm sure all these things are already used, but just for the sake of completeness, I've added that. Inventory control through counting weigh scales. These are some very, very simple, really low cost things which can be done for data capture. So this is also data capture. It is not something, it's not rocket science. It starts even at the inventory level. And inventory data is one of the most difficult data to control and keep track of. Then you can go for a low cost PLC integration with equipment, which will automate few steps of the processes. Then you have power monitoring through energy meter data. So today, one of the important indices of how well your company is run is the amount of energy you consume. So if we keep monitoring that data, we will be able to come up with some ideas to optimize how we run our factories. Actually, we know which month we've made a reasonable return and which month we made a poor return just by looking at our EB bill. The EB bill tells you how much waste has happened in the company, literally. So it's a simple thumb rule by which you can control various metrics in your company. And cycle time monitoring with timers. Then you can go on to the next level with advanced PLCs, which will integrate, which will control the entire process in entirety. Then it can be further upgraded. You can also start pulling data from your temperature controllers. You have networkable temperature controllers which work on Modbus protocol, which can be hooked up, and you can just keep downloading the data. Do nothing, just keep downloading the data. One fine day we will understand what to do with that data. Till then you just keep pulling the data. Then you have various PLCs and controllers where you can, with you can store all the master data for, say a particular mold. You can set what is the, number of degassing cycles, bumping cycle, what is the time in which it has to move up, what is the time in which it has to move down, and the curing cycle. So all those things the masters can be written into the PLC itself, stored in the PLC and recalled. So one level of error is eliminated when you actually, start running the product. Then you have, at the next level, you have network capable PLCs and controllers where you can hold all your master data in a central database. And then on demand, the PLC can pull that data and you can set it up and you can start running your production for that process. So all the process information is controlled centrally. So a technologist can sit in his seat and ensure that all the product process parameters are never meddled with, even by chance or by mistake. So that is the next level of evolution. Then you have creating SCADA dashboards and various custom built solutions for real-time monitoring. So, you can have various displays on your shop floor or alerts which go to your production in charge or quality in charge saying that, this press is idle or this equipment is idle or there is an issue with this equipment or some kind of diagnostic data and so on and so forth. Then, of course, the most critical thing, traceability and logging. So, as a first step, you can go with traceability just through simple barcoding, not with, a complete ERP system, because typically ERP systems, though they are there, are very difficult to implement. And you have to work with the ERP system and you cannot have it as a data entry system in a standalone fashion. If you use it as a standalone data entry system, then you will never get what you want. You will have every step of the way, the ERP system should allow you to pick the next material and it should allow you to go through the next process. Only in that case you will be able to reach the kind of complete traceability that is required. And so as a first step, you can just go with a logging through barcodes and RFID. Later on, you can go for a ERP, MRP kind of integration wherein, a full FIFO control can be achieved and a complete traceability can be achieved. Then you can also have systems where you have process guidance for subsequent process steps based on measurements at previous steps. Say you have a certain result in a previous step. So you can probably slightly tune your process parameters in the subsequent step and manage your production and reduce your internal PPM in a better way and ensure better productivity. And then of course you have use of artificial intelligence and machine learning for various POCA related applications. You have, I think Mr. Chandar was referring to that Takata incident. So now in Rane, ZF Rane, they have a airbag division where the folding of the airbag is actually witnessed by a CCTV camera. So the exact folding sequence is very, very important in the right opening of the seatbelt. And what actually triggers the seatbelt is like a bomb-like device where there's a rapid chemical reaction which fills the airbag instantly. And why it is very important, just as an aside, why it is very important to wear your seatbelt when the airbag inflates is because the airbag opens at such a speed that it can fracture your face muscles. So it is very important that you wear your seatbelt, and that's why if you don't wear your seatbelt, the airbag will not deploy. So they have that kind of a machine learning, system, artificial intelligence system, which actually checks the folding sequence to ensure that there is no error in the airbag. So these are the various, overall, a general captured possibility of how data can be captured, used, and utilized. So what are the opportunities? Why should we be doing all this? So, of course, we are in the fastest growing economy, and car sales has breached 4 million mark, which is a big thing, and is expected to go up further. The two-wheeler market is also very buoyant with very high growth expectation. Of course, now I think with the subsidies on the EV coming down, there has been a drop in EV two-wheeler sales, but that should more than make up for an IC engine sales. So it's all good news for all of us here. And of course, you have a multimodal transport. Right now, there's a lot of thrust in rail movement of goods and even ship movement of goods. There are goods that come from Gujarat to Chennai by ship. They don't come by road or train anymore. So these are very interesting new developments. Of course, you have the China Plus One policy. And you also have, the latest Goldman Sachs report talks about 10 crore people becoming, getting into the affluent bracket by 2027 or 2028. So you will have a whole lot of people spending a lot of money on lifestyle products. So you have a lot of lifestyle products like, probably cell phone covers or various other tactile instruments and, probably various kids' toys and so on and so forth. So there is a huge consumer lifestyle product market which is available, which also is waiting to be tapped, and a lot of it gets imported. So there again, there is a huge market, and we can all work together to tap such markets.
Another important point is very soon we will be the third largest economy.
Yes.
So that is a great opportunity for Indian companies.
Yes. So, of course, there are risks and threats too. So, just 2 more minutes. So, one, just product and platform obsolescence, things like emission norms and REACH and GADSL norms. These may render some of the materials that we are using cannot be used further. So, we need to be really prepared for those kinds of things. And then you have creative destruction, like, of course, EVs versus ICE. Then you have this new age materials that are coming in, and some TPs and TPVs, which may eat into some of our regular businesses that we are doing right now. Then you have disruption. So vehicle scrappage policy is both a opportunity and a threat. So there are people who work purely on the replacement market. So they will have a serious impact due to the vehicle scrappage policy. But on the other hand, people who work on the OE market will have a good time because of the vehicle scrappage policy. And you have various regulatory and environmental concerns. And of course, product liability concerns. Product liabilities, once you get into the product liability space, you understand that it's not a tiger's tail you're holding, it's a dragon's tail you're holding. Because the dragon breathes fire and it can burn you very bad. So technology is key. If you don't have traceability, you're dead. If you don't have process data, you're dead. If you don't have, you're supposed to maintain all records for probably 10 years or PPAP plus 3 years or some duration like that. So if you don't do that, you're dead. So it can, in essence, bankrupt you, literally, and it's a very serious thing. So technology is the only way to go forward. So all technologists here, please also get on to information technology so that we are all safe and India goes a long way ahead. Thank you.
Thank you, Bharti. And now we will hear the technical aspect of MSME sector. Mr. Ghoshal will bring the presentation. Please introduce him.
So now I welcome Mr. Ghoshal, who will be giving the challenges faced by the rubber industry and quality. So he is an expert, almost 2 decades. Though he is from Bengal, he is almost a Madrasi. So almost he is working 2 decades. He is working in Chennai only. He is working in IRP for more than 2 decades. He got a very good experience on automobile and industrial rubber products, compounding and development. He's almost a father of the rubber industry, small scale industry in Chennai. Welcome, Mr. Ghoshal.
Thank you, Mr. Sudhakar, for giving me nice introduction. Thank you, Mr. Janakar, for giving me opportunity to tell something about small scale industries, medium and small scale industries, manufacturing, some problems what we have faced, we are facing to produce quality products. I am in this industry, present industry, for more than 2 decades, and I mainly in the development activities, both compound and product. And what I find that in our present today, of our previous speakers, Mr. Pradeep, Dr. Shankar, Mr. Siddharthan, and Mr. Karthik, and Mr. Chandra, all talked about technology upgradation and how to make the product quality much better and digitalization of these things. And from the medium and small scale industry, what I feel from the last few years on this thing, though we have improved a lot in India, but our mindset has not changed. Many of our end customers, till their quality and design giving a specification to make the best quality product, but buyer expect cheapest material, and they many times they try to compare with our competitor. How the competitor is making component cheaper, that many may not understand. But what I feel that if you have to make the correct quality material as per standard, I am telling here that many standard what we feel is not a correctly as per utilization of the field. It was not made as per requirement, because many standard what I feel is not required. That strict regulation not required. And so, but designers should study what is the actual requirement in the field. If they want the actual requirement, say 80 to 100 degrees centigrade in the field, but they have great specification for 200 degrees centigrade, then what we should do? We have to select polymer accordingly, and which is much more costlier. And who knows the subject, what is the actual field requirement, he may not use a particular polymer which is 200 degrees centigrade. So he may make cheaper varieties, but if we go by specification and standard, we have to use a costlier material. So automatically our component cost will be increased. So in this context, we request to all that especially that people has come from the industries, they should think about this thing. They should educate us to make more study, the design engineer, quality engineer, and make the specification accordingly. Okay, I have got such an experience that I am telling one example. We got one drawing. The drawing calls for that bus pressure requirement is 4 times of the working pressure. And working pressure, the drawing mentioned 10 bar. That means bus pressure should be 40 bar. So we design and develop compound and component accordingly. Then when we get the costing, so our end customer total is very high. We are getting almost 30% or 40% cheaper than this cost from our existing customer. Then I had a talk with the designer, and I told, this is, you have to get the specification, the specification J517, and based on the specification you have to give 40 bar, and we cannot make 40 bar, that is APTM hose, without using Kevlar yarn, and that will be automatically costlier. Then I discussed with him, ultimately he agreed to reduce from 40 bar to 30 bar, and we developed with high strength tensile or high breaking strength for steady yarn, and cost has come down. And unfortunately, I got the sample of that our competitor, and we checked the bus pressure. the first pressure of the competitor sample was 8 bar in place of 40 bar. When I checked, ultimately I got the information, actual field requirement is only 2 bar. And drawing mentioned 10 bar working pressure. So 2 into 4, 8 bar, he has given 8 bar correct. But he knew that he made it. But I can tell, he has not made as per specification. So when I tried to make as per specification, and designer didn't know actually what is the field requirement, then the people or the manufacturer who is making honest way, try to make component as per standard, then he will failure, he will not get the order. It's happening. So in my previous speakers, all the speakers talked about the digitalization, talked about the so many other quality aspect of this thing. But in India, till many of our end customers, still they are thinking of the rate is the main concern. But when we are going for this thing, BS6, say, then quality you have to think about. One incident I'm telling about this, that two-wheeler, this thing, when we got the drawing from two-wheeler company, one company, and when, based on standard, when we get the costing, and when they told they are getting this rate, by that rate we will not be able to buy the raw materials. How they are getting, I do not know. Maybe either specification wrong, what is actual required in the field, it is not actually given in the specification. Okay, so that's why we are not in the field of making two-wheeler components. That is so cheap. I do not know that, but I have got a good faith on the infield. I know that infield quality is very good. But problem is that the specification they actually need, or actually the field what is actually required, different. Okay, so there is a scope of some of the companies who knows the actual thing, they can make cheaper material. But the company who are those companies who are making honest rate, they will be failure. That's why we are not in the two-wheeler component manufacturing company. This thing. So this is this thing. So I request that present gatherings try to check with your designer, with the quality people, what is the actual requirement. I don't want that unnecessary cost should increase. But at the same time, the specification what is made, that should be realistic. So this is one point. Second thing is that to make the quality product, we have to think about how the life cycles can be increased. Nowadays, as Mr. Pradeep told, we are making many components nowadays, but requirement is very strict, especially that turbocharger application, where we are using mainly silicon hose with polyester reinforcement. Nowadays, it is changed to polyester to aramide fabric, mainly meta-aramide, and silicon outer, inner is FK. In some cases, some company they ask for fluorosilicon to meet that low temperature properties. So in this type of this thing, there is some fallacies there. In all cases, it is not required. It depends on the, suppose we got one component, it is called intercooler out. Intercooler out, temperature requirement 80 to 100 degrees centigrade. Drawing calls for silicon, FKM, aramide fabric. So when we checked with the designer, he told this is the requirement, and we requested these can be developed with nitrile neoprene with polyester, because your specification will be, your requirement will be met. So you have to change the specification accordingly. And he told, okay, you make the component, we'll make a field trial, and then we made the component, and the component gave more than 1 lakh cycles, which is required, and ultimately they changed that design. And price has come down to that particular component from 900 rupees to 350 rupees. So it is one of much savings. At the same time, we are made the component as per specification. But if it is not made, then what would happen? We may not get that order. Okay. Somebody made, Somebody may make without giving a cane process or anything. Okay. It has happened. I am talking about 7 8 years back. We made hose 100% silicon with glass fiber reinforcement. Okay. Now what happened due to glass fiber abrasion? There are some pieces. That yarn got cut. Okay, and failure was there. So I got a call from the metallurgist. He told that someone told, our computer told, you have to make it with silicon with Nomex fabric. Okay. And I told, okay, only Nomex is okay, but fluorosilicon inside is not because he's telling that this may be failure, maybe due to the oil contamination inside the hole. So I don't know. It is not the case. It is only due to glass fiber. So what I request, please change glass fiber to aramid. Then he told, no, it is not possible. I am changing the specification. And he changed the specification. And ultimately, we lose the order. Okay. After 3 years back, he told me after 3 years that, Mr. Ghoshal, the one thing I am telling, that company didn't use fluorosilicon at all. Okay. He used silicon only with aramid fabric. And what happened? They have paid the price of fluorosilicon, but they got the only silicon, and unnecessarily they lost, their company lost at least more than 1 crore rupee in 3 years. And we lost the business of 3 years. So here, only I request all the concerned people, wherever is there, tell the designer of this thing, try to make that specification, take the drawing as per realistic way. Okay. Then you will get the benefit, definitely. Now, my present, now you think that we are going from car driving to final car, then vehicle, then bus and lorry. The two-wheeler, this 1 minute, say two-wheeler, lot of components required. Okay, what I think, some of the components is very, we should consider the safety factor, like the damper, then some of the hose items, so the oils is very important for two-wheelers. Okay, and but safety factor, how they are meeting or not, I do not know. We are not making the two-wheelers parts, but I have seen the specification. Specification is quite rigid. Okay, and the gasket also quite high. So that life and safety, it depends on the rubber parts. So whatever regulation we maintain, okay, digitalization or maintain, if you are not able to produce part as per requirement, as per actual requirement, then I do not know whether what is the life of the vehicle. But most of the companies producing in India, their life I heard are quite good. But I do not know how they are giving so cheap rate. Okay, this matter we have to think about. Okay, next slide. Now this is a very important aspect now. Nowadays for the fuel, this is a turbocharger application. Turbocharger is a very important aspect nowadays. After normally V6, this is very important, and for this application, this I told you silicon, fluorosilicon, and aramid fabric hose is very important. Here, this thing that exhaust gas which contains carbon dioxide, carbon monoxide, and nitrous oxide, that gas, if we freely release in the environment, lot of pollution will be there. So that gas, temperature is also high. We can use that gas to run the turbine or the turbocharger machine, the equipment. The turbine in turn will compress that air. That air will enter the engine at high oxygen concentration level, where we can use more fuel, and this fuel efficiency also will be increased. We'll get in a smaller engine, we can get more power, and ultimately that exhaust gas what we release in the environment, that will contain much less carbon dioxide, carbon monoxide, and oxide. This is the main purpose of use of turbocharger, which is a fuel economy, and pollution control also will be very good. At the same time, that engine size, nowadays for the vehicle, engine size is small. So engine size will be also small. Only one disadvantage is that under the bonnet temperature will be high. So accordingly, you have to select the polymer and we have to make some slight changes in the design. Next slide. This is also part of turbocharger. You will find this thing, the exhaust manifold. Then so exhaust manifold. So that turbine is running the compressor, and through shaft we are getting air. That air is compressed. It is going to the engine at high oxygen level, and where we are putting the fuel and fuel injection, and ultimately we are getting high power. And finally, that exhaust gas is released into the environment, which much less polluted. This is the basic construction of or use of turbocharger. The turbocharger is mass for diesel engine, for truck mainly. Nowadays it is used in four-wheeler also to get much better fuel economy and less pollution. Next. This is the four-wheeler. We are using various parts of the four-wheeler. Though we are not the Tier 1 supplier to four-wheeler parts, we are the Tier 2 supplier. But we are our parts are going to Hyundai, Maruti, and many other four-wheeler making company, and some of the assembly part companies like Rane Groups we are supplying. Here, very important part is that oil seals, hoses, and some gaskets. And another point is I forgot to tell, for a higher capacity vehicle or higher tonnage vehicle, buses and trucks, another very important thing is that the rocker cover gasket. Where initially rocker cover gasket was developed with polyester because it requires high temperature, high oil resistance. Then subsequently it has been changed to AEM, and now many cases it has been changed to FK because now designer is thinking the temperature is going up. But I feel AEM may be suitable for many applications if we make the component in proper way. But anyway, SCM, AEM and rocker and FK is going on, they used in the rocker gasket application. Then another important part in the automobiles is that hose. The EPDM hose is, for so many years, EPDM hose was used in the radiator hose application because EPDM is the best resistant to coolant, EPDM rubber. And normally EPDM hose is made out of sulfur. And many years people are using, or OEMs are using EPDM sulfur cure, and it is meeting quite all the properties, except minor heat resistant properties. It can stand maximum 130 to 135 degrees centigrade normal. But recently, in the European or US market, that most of the hoses it is perovskite cure. Mr. Pudikwa has already mentioned that perovskite hose, perovskite cure, that is called electrochemical degradation resistance. So due to electrochemical degradation, in some cases, the inside of the hose, there is some small crack. Through that crack, that coolant flow inside is going inside, and the hose got damaged or busted. And what is the electrochemical degradation? Any hose, EPDM hose, there is a two ends, two couplings or two metal ends are there. They are material, I think, zinc alloys or copper made. That end fittings are used as the electrode, and coolant is using as electrolyte. So there is a static electric charge develops at certain temperature, and that electric charge damages the inner portion of the hose. And as the purity salt we are using, accelerator and all this thing, that breaks down to some ions. So some ionic reaction takes place and breaks. So study has been made, and it has been it has been analyzed that if we convert to peroxide, then ion generation of ion will be very less, and this type of degradation may not occur. So nowadays, all the ECD hoses made out of peroxide we are also making, and we are supplying to our end customer. They are also happy. Another thing is the advantage is there. Peroxide cured component, compressor set is better. So when the frequency of tightening the clamp is much reduced. If clamp is loose, then lot of loss of coolant. And when I went to design section about 4 or 5 years back, they used to tell Mr. Kushal, you try to do something. There is a lot of losses in coolant. And so I told there is a two-way we can. This is advantage two ways using peroxide. One is ECD resistance, another is the compressor set will be very low, very good. So you can that frequency of putting tightening that clamp will be very less. So you will your loss due to coolant loss will be very less. So we have started supplying. We have started development activities before the corona activities, and we have made up 3-4 years of study thoroughly. We have made all sort of testing, especially electrical integration test. We have made at least our hose we have tested 50 times, and whenever any changes is there due to non-availability of polymer or chemical, we check the ECD resistance. And so far I got the information, quality-wise no problem. So this is the thing, what we think, but the problem is that here one disadvantage is there, with peroxide we have to post-cure. Post-cure is another extra operation. So price-wise automatically it will be increased a little bit. So that thing, definitely our OEM should consider this thing. If they think that the price of peroxide hose will be like sulfur cure, it cannot be given. So now my main observation is that we can make the component as per specification, which will be good quality, but sometimes it may not be cost competitive. Okay, if we think about other competitors that are giving a cheaper price. So here, all that our dignitaries, especially the OEM sectors, they should think about that only if we think that we make the quality product, that is okay. You make the digitalization, you make an electric vehicle, you make hydrogen fuel vehicle, all these things possible. But at the same time, we should not think about only that final cost of the component. Cost and quality should match. Okay, then only you can develop, or the vehicle life will go up like anything. This is, you see that first one silicon hose with aramid fabric. Second also silicon hose with polyester reinforcement. It depends what is the temperature required. This temperature is 200 plus. This is about 140 as per specification. So if we think of, if we analyze properly what is the actual field requirement, definitely we can able to reduce the cost. But if your requirement is very stringent, and at the same time you want cheap cost, then I don't know. You will not be able to make this thing, but somebody will make, but that component may not be as per specification. Okay. So as many times I have observed also. So this is the only my request, that when I can give the message to the general technologist here, along with all the OEMs, that you talk to the designer, and designer also should interact with their manufacturer. They should visit the manufacturer place, and they should get more information, more technological information, so that they can serve their own company in much better way. Okay. Only they think that they are saving money wise, it is not the right thing. Okay. So anyway, I don't want to. This is all the part. Just engine part. So many things: engine mounts, diaphragms, gasoline, head gaskets. A head gasket, the Dr. Baba was talking about. Fuel and emission system. Nowadays, fuel and emission system is quite strict. So to maintain that thing, we have to use correct polymer. So what are the polymer? Because that specification is very stringent, and in most cases it is either FKM or HAMAC or polyacrylic. Okay. Based on this thing, we have to make this thing. That naturally the component cost also will be increased. An engine cooling system. This coolant hose. That's how I described. Coolant hose mainly earlier made out of EPD rubber with polyester reinforcement and superfluous rubber. Nowadays, in most of the cases, one industry, all the coolant hose they converted to peroxide cured hose. Till some companies they are using combined superfluous hose and ECD hose. And washers also, according to depending on the temperature or fuel requirement, we have to set as a polymer. Engine lubrication system. This is also very important. This thing here, lubrication purpose we are using various oils, and temperature is also high. According to the temperature, we have to select. Here also mainly AEM or FKM are used. Oils is also like that. Sometimes polyacrylic is also used. So we have to get the correct information, then we can develop component with proper quality and optimum cost. Transmission system. Here also gaskets, rear seals, radiator sub-seals, all are specific requirements depending on the specific type of polymers. Okay, so next. Powertrain system. Powertrain system, here drive shafts is thinking, this is also that thrust is very important. So here construction of the component and selection of the polymer very important. Here also the temperature is high, normally high temperature, and oil resistance properties also should be good. So accordingly we are selecting the polymer. Access system. Access system, bearing seals, access seals, okay. And CBJ boots, wheel, and all these things, all more or less, all this special polymer. It is not that like a normal polymer like a NR, SBR, polybutyl and all these things. It cannot be used. Power steering hoses, boots, cups, hoses, input set, same thing. I think we should not elaborate all these things. All these things all require special requirements, or because without this special polymer or special design, it cannot give life. So I don't want to elaborate this thing. All these things like this. Brake system, brake cup is very important. Recently I had got an experience. One company, they found a problem in their brake system. We are supplying to them hoses, brake hose, and they found their seal. They are using sub-seal. Their seal is in somewhere in some country, African country. The seal, their component, their engine is, the seal is swelling. So they analyzed, they found that coolant contains some chemical which is actually that reason of swelling of the diaphragm or that seal. So when they contacted us and they requested to develop modify this thing, we have studied and we have modified that coolant, quantity of oils. This is basically phthalate based oil. That quantity of phthalate based oil we reduce this thing, and ultimately we found it is okay, and they are very successful, and that all this testing they have done, and that material they have sent this abroad and found successful. So this, if you get the correct information from the end customer, we can change that formulation or specification accordingly can develop. Okay. So suspension system. this is soft absorber bellows, vibration mounts, springs. It is all engineering material. Here the depletion parameters are very important. So accordingly, you have to select that compound formulation. Okay. And in many cases, it is natural rubber also can be used. And wiper seals, maybe you can use EPDM rubber. Various O-rings, it depends on the temperature requirement and type of oil we are using. Then air conditioning system, air duct hose, compressor diaphragms, duct hoses, depending on the requirement. Mainly EPDM type hose, the polymer can be used here, but some other polymers also can be used. So I think I should not elaborate much. So thank you. And again, I request all the gatherings to think about it. Thank you.
Thank you, Professor. Already you are running late, so maybe we can give 5 minutes for question and answer because there's going to be dinner. So you can also interact with the speakers for their clarification discussions. And also, if you want to refer some specificity, you can write to us. We can forward the query to the speakers. So now another 5 minutes we spent for question answer session. Please get up. Put your name and the name of the organization and ask for questions.
Good evening, everyone. I am Dalit Kumar, ex-DGM MR Karakoram. My question is to Mr. Pradeep Ji. See, I have seen that you have requested for mark warrant for anti-vibration mounts and like that for 2 lakh kilograms. On what basis that was arrived? If you could explain, it will help manufacturers develop better products.
I think this requires an elaborate discussion in the first place. But if you really look at the Indian terrain conditions are like that, and there are stringent qualification methods are there. Our 6-poster, 4-poster testing methods are stringent, and we are also constantly looking at the marketplace, how the mounts are performing, right? And in my experience in Ashok for the past 23 years or whatever, I have been seeing 4 or 5 times the specification has been changed. Yeah, from the initially it was 5 lakh, the vibration hours. Then the vibration frequency was changed. Lot of innovation has taken place in there. And really looking at future is towards suspension damping in that area. That is what is happening with one of the major suppliers. We can discuss it.
Thank you, sir. Thank you.
Anybody else?
Anyway, this question I was talking to Dr. Shankar because regarding sustainability of EV vehicle, especially the battery, that lithium and cobalt is not good for health. So how this thing can be solved? Because I heard that lithium, if you have to save the harmful effect of lithium, you should keep it under the soil. So it is not possible when if all the vehicle is converted to electric vehicle. There is so much lithium. How after 3 years, supposedly after 3 years, you have to change the battery. So how you can protect that human body, human life from the lithium? You cannot burn. So you have to only put under the earth. It is not always possible. So anyway, Dr. Shankar has left. So just I put this question to the general body. They can think about. So electric vehicle may not be sustainable in that case. Because that electric battery is the most important part. And lithium and cobalt is the main material for electric battery.
Recycling their battery pack.
But lithium cannot be recycled. Not lithium, only I am talking lithium cobalt. Okay. Okay.
It will be better if you people can more relaxed way discuss when the dinner is going on, networking dinner. Now I request Mr. Ganesh to propose a vote of thanks.
Good evening to all. First of all, I would like to thank MRF management to come forward to sponsor this event for the benefit of MSME sector. I would like to mention few names. Mr. Cherian, Mr. Shaiju and Dr. Srikumar Nair have coordinated and made this event grand success. Can we give a big round of applause? I would like to thank Mr. Pradeep Kumar, DGM Strategic Sourcing Ashok Leland, Dr. Shankar Venugopal, Mahendra and Mahendra, Mr. Chandar from Royal Enfield, Mr. Ganesh from Yamaha, Mr. Karthik from AIRI, and Mr. Ghoshal for giving a good lecture. Please give a good round of applause. Special thanks to Mr. Davidson of Fenner, Mr. Natesh Kumar from Fenner, and Shrikant from Alpha Rubber, who couldn't come. He has helped us to organize the speakers. Thanks a lot to them. I would like to thank, of course, it's like a family. However, formally I have to say, Mr. Janakar has taken a lot of interest in organizing this seminar. Thanks a lot. I thank Mr. Hariharan of IRI and Mr. Muthusamy of Altech, who was selfless in organizing this meeting for marketing this event. I would like to thank Hotel Aditya Management, Mr. Joshua GM, Mrs. Shalini and Mr. Neerbandan for organizing this event. Last but not least, I thank each one of you. You have taken a lot of your time, that too on a Saturday, and some of you have come from Hosur and Coimbatore and all for attending this meeting. So thanks a lot for all of you. We will be conducting a IRCO RubberCon meeting at Lee Meridian Hotel, Cochin on 5th to 7th December. We will be sending the circular very soon. Please, I request all of you to attend that event. Also, we will be conducting, as Mr. Janakar said, we will be conducting PGDRA and DARA classes, maybe from within 2 weeks. I think we have seen a lot of new faces. I request all of you to enroll yourself as the member, and also you can write PGDRA, DRA exam so that you can grow in your career. All the best to all of you. Thanks a lot. We request all of you to join for cocktail and dinner that has been sponsored by MRF. Please enjoy, have a nice time, and whatever queries you have, you can interact with all the speakers in a relaxed way.